final module highlights the importance of facility layout and design as an important component of a business overall operation, both in terms of maximizing the effectiveness of the production process and meeting the needs of the employees. We are going to discuss in the apparel manufacturing. The next important topic what we are going to discuss today is basically plant location and plant layout. So this we are going to discuss about the plant location, where we want to locate the factory and what layout we are going to follow for that particular manufacturing plant. So these are the words are the location and layout of the plant. So we will discuss about the first. We will discuss about the objective. So what are the concepts of there? What are the objective? Basically, in objectives, we will discuss about the plant location and plant layout. What basically we are going to learn in this particular module. The basically is to identify the various factors to be considered for selection of plant location from state, area to the any specific site. Basically, where we want to set up our plant, that's very important. Which area you want to set up the plant? If you want to set up the plant in Asia, Europe, Africa, which place you want to set up the plant, that is very important. And to do the locational analysis, suppose in Asia we chose the Asia as a location where we want to set up the plant because of the availability of maybe the raw material, availability of manpower and availability of machine also. So we have taken the area as Asia. In Asia we wanted to set up the factory in India. In India, what are the SWOT analysis? We will do the SWOT analysis to understand that why we want to set up the factory in India. Suppose we want to have the some skilled manpower you want to have. Say in India has the opportunity where we have the more skilled manpowers are there, and we want to set up the factory in which part of India. That is another word comes in the mind. This is the another question used to come into the mind. So in India we want to set up the factory in, we have the different clusters are there. We are in India, we have the NCR, the National Capital Region is the one cluster where we are the Delhi and other suburb areas are there. Then we are having the areas in south, we are having the Chennai, we are having the cluster of Bangalore, we are having the cluster of Tirupur. In west we have the cluster is Mumbai and Ahmedabad, those are the major cluster. In north, sorry, in east we are having the Kolkata and those clusters are there. So basically, suppose we are looking for some basic product and we are choosing the and each and every cluster has some advantages and they have some SWOT is there for SWOT analysis, strength, weakness, opportunity and threat is there. So we are having the basic products, like we are going to have the shirt production or trouser production. So we have selected the area maybe in the South India. In South India we have taken the area at Chennai. So in Chennai we want to set up the factory, which the factory should produce the shirt and trouser. So for that we have selected the factory in Chennai. So Chennai we should also understand, if you want to set up the factory in Chennai, what is the minimum wages for the manpower, what are the land cost is here, what is the availability of raw material we are having, what type the government subsidies we are going to get, what type the electricity facilities are there. So these all things, how many SEZ is there, special economic zone is SEZ. We want to have the export order, or you want to have the for the domestic, we want to cater for domestic or we want to cater for export. Suppose we are going to cater for exports, so we want to set up the factory in EPZ, export promotion zone, or you want to set up the factory somewhere else. So these all things are there and we have to go into detail to do the analysis, the complete analysis about these location, where we want to have the location, what are the factors are there. Those things we are going to discuss in detail in that, and then after we will come, once the location analysis is done, then after we will come on the layout of the factory or layout of the plant. So here we have taken the example like we want to set up the factory in Chennai, doing all sort of the SWOT analysis, and we want to set up the factory in Chennai. In Chennai, which area we want to set up the factory? We want to set up the factory in suburb of Chennai. We want to set up the factory is very close to Chennai. So those things comes into mind. So basically here we are going to discuss about identify the various factors. What are the factors will come across to be considered for selection of plant location from state or area to the specific site. So we have to take those factors into consideration for the selection of the plant location. Then after next objective is basically distinguish among the alternative patterns of the plant layout. What are the different type of patterns are there for the layout? Next, different type of the layout patterns are there, different shapes of the layout are there. Some layouts are zigzag layouts, some layouts are straight line layout, some layouts are basically U-shaped layout. So those things we will discuss, like some layouts follow like this straight line direction, where basically maybe fabric store is here. Then next is basically the cutting room. Then next one is we need the bigger area for the sewing. So suppose this is sewing, and next is finishing, and next is packing. In between somewhere, if the factory needs washing, then washing will also be taken care of that. So basically it depends on that what are the basically SOP says, what are the standing operating procedures are there for that particular that particular product. Those things has to be taken consideration. But mean to say that I just want to explain this is a part of the straight line layout. Then we are having the layouts are basically, which is the U-shape layout. Like some layouts are like this, where basically this is the fabric store. Then we are having the cutting area. Then maybe this complete area is for sewing. Then next is finishing, and this is basically the pack goods area, packing area. Okay, in between these are the areas where they are keeping as a office areas for offices, or maybe for merchandising, some pre-production, for sampling, for HR, maybe we are having for receptions. So these are the different areas, and for the cabins are also there for the senior manager, for the middle management, and we may have, this is the road area where basically the truck will unload the goods here, and then it will unload the fabric. The truck can move this side here. They will we are having the loading bay. So this is the loading bay where the loading will be done. This is the area where the unloading of the fabric will be done. The major area of the fabric or trims accessories will be unloaded here, and the pack goods will be loaded here. So different type of the layouts are there. These are the few layouts we just I just want to make it here so that it's very clear. Like the straight line layout, it starts from the fabric store, then cutting, then sewing, then finishing, then packing, and so many other departments. So this is the flow is there basically in the straight line. We are talking about the next layout is what I mentioned here. This is the U-shape layout, where U-shape layout, the fabric store is there one side, then after cutting, then the whole area is the sewing, the other, this area, the shape is there with sewing, then we have the finishing, then packing, and in between we have the area where basically all offices can be accommodated in this particular area. So different type of the layouts are there, different type of the patterns are there for the plant layout, that we will discuss in this particular. This is the objective of one of the objective I have discussed about these are the different patterns are there, the layout. Then we will discuss the various factors influencing the choice of initial layout and in subsequent modifications. So different type of factors are there which basically influence the choice of the layout. So those things, and what are the modifications are the, what are the different, we will also discuss here the expansions, whatever the layout we are going to make. What are the future expansions are? Suppose right now we have made a layout keeping in mind that every day we have to produce 1000 pieces of shirt. That shirt is already the SAM of the shirt is maybe 20 is a SAM. And we are going to produce the shirt which is basically the basic shirt, and we want to produce per day 1000 pieces based on what type the order we will get. Now maybe after 5 years or down the line of 7 years down the line, we come to know that we are having the more orders. We are going to produce, we are getting more inquiry from the buyer, and they want us to produce more shirts. They want to give more orders. So whether we have any future plan is there, whether we can go for the expansion in the same factory, whether we will go for vertical expansion or we can go with the horizontal expansion, vertical expansion like that. We are going to make the another floor or another floors where we can accommodate those orders, or we can have the horizontal means like we have the having the land area is there, which area we can utilize further for expansion of our factory. So either it's vertical expansion or it's horizontal expansion, whatever the expansion is there, that is the future plan has to be taken care once the layout has been made. That is the good layout where basically these all features has been added. So as we discussed like the factors, we have discussed about the different factors. So now we come to know about the what exactly the plant is, what exactly the factory is. A plant is a place where man is the man, maybe we have the operators, we have the helpers, we have the different mans are there, supervisors, we have the different middle management is there, we have the first line manager, middle managers, top line managers, we have the like laborers are there, direct laborers, indirect laborers. So like the different manpowers are there. So the layout is basically the plant is a place where these different types of mans are there. Different materials we will talk about. We have having the raw material, we have having the finished products. Raw material we can have the fabric, we have the trims, different type of trims and accessories are there. So these machine and material, whatever the materials we have discussed, then different type of machines are there. We can have the cutting machines, we are having the sewing machines, we are having the finishing machine in cutting machines, we are going to have the CNC cutter machine, that automatic cutting machines, or we are having the semi-automatic like the band knife, we are having the straight knife, we are having the round knife, or we are using the manually like the scissor we are using for the cutting. The same for in the sewing, we are having the straight single little lock stitch machine. We are going for overlock, flat lock, or buttonhole, button attach. So whatever the types of the machines are there. So whether it's a man, whether it's a machine, whether it's material. So basically the plant is a place where all this man, machine, material, equipments are brought together for manufacturing of a product. So it's giving the one place is there where under one roof the whole these all 3 M's can be worked together: man, machine, material and equipments. So now next we'll discuss about the different, what are the the factors which affects these factory location or plant locations. Why we are choosing any particular location, why we are going to discuss on that particular thing. The factor, what factor we will discuss about which are affecting the plant locations are the nearest to the raw material. The first factor is basically we discuss about the nearest to the raw material. Where we want to set up the factory should be nearer to the raw material, because how far it is from the place, because raw material, the complete product, we are going to make the finished product, and input is raw material and output is finished product. So raw material, from where we are getting the raw material, that's a big question mark. Whether is nearby the vicinity or is very far, that also decide on the location. Like if the raw materials are very close by, then it's an advantage in that particular area to set up the factory, because the transportation cost can be reduced, the time of the transportation can be reduced. The person, the factory have the more you can say more say on, because if it's very nearby, so definitely whatever the changes has to be made has been done, it can be accommodated very fast, because the time and money, those things can be saved in this particular case. Then definitely the transport facilities, wherever we want to set up the factory, what type of transport is there, what type the routes are there, what type the public transport is there, what type the private transports are there. These all things are important, so that the worker as in the garment manufacturing factories, basically unit is basically the manpower driven, where the major manpowers are required for this type of the plant. So the transportation is required for man to transport the man, machine, material also. Then next is the nearest to the market is how far this is from the marketplace, shopping place, where basically shopping is not that much is related, directly related to the manufacturing, but the marketplace is required where basically the spare parts, we can get the spare parts if there's some problem happen in the machine or some machine breakdown happened. So we can have the place where we can get the spare parts. We can have the other allied materials are there, which is also used, like in the washing we require the different type of detergents and all. We in finishing we require the spot gun. So different type of the products are also required. So how far it is from the marketplace, where basically the day-to-day things can also be taken care, like lunch, dinner and all. So if the operator wants to have their food, so they can have the nearby, and the marketplace is there. From there the food can be buy, although the canteen is there, but some tea breaks or whatever the breaks has been given, it can be done, which can be sourced from the market. So how we can source those materials which except the raw materials of the factory, raw materials for the production what we are using. Apart from that, what are the different materials are there which can be sourced from the factory for the sourced from those shopping areas. So nearest to the market is another important factor is there. Then availability of the labor, where we want to set up the factory. I told you that the garment manufacturing factory plants are basically the labor driven. So manpower is required, operators are required to operate the sewing machines, to operate the cutting machine, to operate the finishing machines. The helpers are required, the middle management, first line managers are required, like the supervisor, team leaders and all. Middle management are required to execute the complete the plan. Then top line managements are required. So this basically to understand that what is the availability of the manpower in that particular area. So this is another deciding factor where we want to set up the factory. Nowadays the factories are moving from cities, heart of the cities, to the areas like the villages. Or if you talk of the example of in India, especially in NCR and in Bangalore, in Chennai itself, the factories are not in, no, they are moving from the city to maybe 40, 50, 100 kilometer far from the main city, or even 150 kilometer also, because of they are finding more labors in those areas, in the villages, where they will train the manpower, and then those manpower can be utilized for their in the factory for their production or manufacturing. So nowadays the factory is moving to outskirts from the city. So that is the availability of the raw material, availability of the manpower is very, very important. What is the proximity of the manpower to that particular factory? That is very, very important. The next is the availability of fuel and power. The fuel and power is very much required, because most of the machines are power driven machines. They need the power, they need the electricity, they need the fuel. So what is the availability of the power? What is the electricity? What type of electricity is there? What is the power, in 24 hours of time, how many hours you are getting the power on average? So these things are very, very important. Then fuel, in the case of if there is no electricity, then genset or whatever we are keeping, so from where they will get the diesel or whatever the fuel requirements are there. So these availability are also important. Then availability of the water, whether the water is salty or whether the water is drinkable, or whether we have to make it drinkable. So whatever the water availability, what is the water availability? How many feet we have to bore to get the water, or whether we are getting any corporation water or not from the government, what type of subsidy they are getting on the water. So these all things are very, very important. What is the availability of the water is there, because for drinking also we need the water. If you are keeping the canteen, then food making also we need the water. Even washing and all, major water we required apart from the toilet and flush. So water is important to understand what type the availability of the water is there in that area. That is also next important point. Then the condition of the climate, whether the climate is hot and humid, or climate is cold, or is a moderate climate, that is another factor. So whether if it is a hot climate is there, then definitely we have to make sure, because we have some standards, some guidance are there which has to be followed, which has been given by International Labour Organization, ILO, has given some guidance is there. So that guidance has to be followed. If it is the very humid factory, inside the factory very humid is there, definitely the efficiency of the of manpower will not get the if it is very cold, or in extreme cases also, both the extreme cases is not suitable to work. So the climate condition is very, very important, that where you want to set up the factory, what is the climate conditions, and accordingly what type we are going to have, what type of we are going to have a fan, or we want to have the factory with the AC, or we want to put the air cooler in the factory. So these things are has to be planned based on the climate condition. And the land, availability of the land is also very, very important. What is the land cost, what is the availability of the land. So these all factors what I have discussed, these all factors are important in terms of setting up the plant, where you want to set up the plant. So now we'll discuss about the location, about the plant location. What basically we talk about the plant location. Every entrepreneurs, or every whoever wants to set up the factory or plant is faced with the problem of deciding the best site for location of his or her factory. So location of the factory is always challenging for an entrepreneur. Where they want to set up the factory, they may not be getting that, because after doing the SWOT analysis, they are finding that maybe it will not be a fruitful decision. So it's very, it's always they are having the brainstorming session once they want to decide about the location of the factory. So next question comes, what is the plant location? The plant location refers to the choice of a region. Plant location refers to the choice of the region and the selection of a particular site for setting up a business or a factory. Where you want to select, what are the choice, on which region you want to do, that is so setting up a business or factory. But the choice is made only after considering cost and benefits of different, we are going to take the cost and benefits of different alternative sites. We will do the SWOT analysis of what I told, we will take the different benefit, what are the benefit is there in that particular location, and what is the cost is there. So these things we will take into consideration. Then it is a strategic decision that cannot be changed once taken. So it's not like that every day you are changing the product or you are changing the manpower or equipment. This is strategic. Once it has been made, you have gone for the purchase of the land, you have started the making of the building, or factory is ready. So it cannot be changed every time. It's a one-time decision. We have the entrepreneur has to take, but so much of energy, so much of cost used to involve, so much of planning used to be involved once a factory has to be set up, or once the factory has already decided that what is the location of the factory. If it all changed in only at considerable loss, the location should be selected as per its own requirement and circumstances. It has to be discussed, it has to be selected, it has to be what are the circumstances are there for the location selection, what are the requirements are there. These are the prerequisite to before you have gone ahead with this selection or finalization of the location of the plant. So next question comes, what is an ideal location where we should have the factory? What is the ideal location is there? An ideal location is one where the cost of product is kept in minimum. The product cost has to be kept in minimum. That is the main mantra, is that. Whether we are going to increase the productivity, whether we are going to increase the efficiency, or we are going to reduce the cost of production, whatever the way is there, the cost of product has to be kept low. And the least risk and the maximum. Second is basically the low cost. Second thing is that the least risk and maximum social gain. It should not have the risk factor should not be there. Like the factories which the plant is there in the some areas, some countries which are having so many disturbances are there in the country, or in that particular location so many maybe the different disturbance are there. So whether if the risk factor is there in that particular factory, maybe the factory will be in a month time, 5 days or 10 days there is a strike. So many factors can happen. So those risk factor has to be taken care if you are having the where you want to set up the factory. So location is very, very important to understand that the risk factor should be minimum. And the maximum social gain in terms of that we are taking those society also, we are taking them, and you are also making them happier. It's a win-win situation for society also, where you want to have the factory, where they also feel like they are also part of this particular the move has been taken forward. So it is the place of maximum net advantage, and we can say that, which gives lowest unit cost of the production and distribution. For achieving this objective, we can make use of location analysis, what we discussed about the location analysis for this particular purpose. Then location analysis is basically a dynamic process where entrepreneur analyzes and compares the approximateness or otherwise the alternative sites within which the aim of selecting the best site for a given enterprise. So is the location analysis is a dynamic process where basically the entrepreneur analyzes and compare these other different alternative options, and then after they used to finalize those options. So this location analysis has different factors are there. What are the factors are there? I am going to discuss on that particular factor. One factor is demographic analysis. It involves study of the population in the area in terms of total population in numbers, the age composition, the per capita income, the educational level, occupational structure, etc. So demographic analysis is required for that particular area to understand that the population, what type of the population is there, what is the cost, what is the number of the population is there, what is gender, ratio is there of the population, what are the age, how many people are there with some certain age group, how many teenagers are there, how many persons are there which is 19 to maybe the age group of 25 to 35, like we have a different age groups, which how many people will fall in different age group, what is the social conditions are there, requirements are there in that particular area. So those things has to be analyzed during this particular phase. The next is basically the trade analysis, that is called trade area analysis. So it is an analysis of the geographical area that provides continued clientele to the firm. He or she would also see the feasibility of accessing the trade area from alternative sites. So this is basically the trade area analysis. After this particular next phase is basically the competitive analysis. It helps to judge the nature, location, size and quantity of competitiveness in that given trade area. Like in that particular area, what is the competition, what are the, whether there are any manufacturers are there which are also dealing in the similar type of the product categories. This is the competitive area in terms of location, in terms of nature, in terms of size, in terms of quality. So these all things has to be checked in the competitive analysis phase. And next is basically the traffic analysis. To have a rough idea about the number of potential customers passing by proposed site during the working hours of the shop. The traffic analysis aimed at judging the alternate sites in terms of pedestrian and vehicular traffic passing a site. So analyze the traffic conditions, what are the traffic conditions are there, how many vehicles are passing, what type of the different type of traffics are there. So those things has to be checked also, has to be done, study has to be done during this particular phase. Next is basically the site economics. Site economics is basically the alternative sites are evaluated in terms of establishment cost and operational cost. Under this, cost of establishment is basically cost incurred for permanent physical facilities, but operational costs are incurred for running business on day-to-day basis. So these are the, and then it's this particular operational cost is also known as the running cost. So every day how much we are paying, how much we are using, how much transaction we are doing, those comes under this particular phase. And then next is basically the selection criteria of this particular location. So the important consideration for selecting a suitable locations are basically the natural or climatic conditions. We have discussed already earlier what are the natural conditions are there, what are the climatic conditions are there. We have discussed about the sources of the raw material also. We discussed about the transport cost, what are the transport costs are there for raw material and distribution for the market. Again, once the raw material is coming, and then after we have to send the finished product to the market, that is the cost, how much is there. Access to the market, that is small business in retail, how much access is there. Availability of raw material infrastructure facilities such as developed industrial shade or site or link roads nearest to the railway station, airport, seaports. Availability of the electricity, water, public utility, civil amenities, means of communications. These all things are very, very important, especially for a small manufacturer. Then next is the availability of the skilled and non-skilled labor and technically qualified and trained managers also, because each and every stage we have the direct labor stage, we require the how many skilled and non-skilled labors availability is there. Then first line stage we have to see that how many trained manpowers are there who can be taken care, who will take care as a supervisor, who can be recruited as team leaders. Then how many production managers are there in that particular localities, availability of that particular level, then availability of the top managers. So these all things we have to see that. Basically we have to see the availability of on the direct labor stage. And then banking financial institutions are located nearby, because every day maybe the transaction, some bank transaction has to be required. So how far the banking and financial institutes are there, that also next point to be checked. The location with the links to develop the industrial areas or business centers result in saving or cost reduction in transport overheads, miscellaneous expenses. The next is strategic consideration of safety and security should be given due importance also. Next one is government influence, both positive and negative incentive to motivate an entrepreneur to choose a particular location are made available. Positive includes the cheap overhead facility like electricity, banking, transport, tax relief, subsidiary liberalization. Negative incentives are in form of restrictions for setting up industry in urban areas or for reasons of pollution control and decentralization of industries. So these are the different we have discussed about the once any factory we want to set up, different type of the locations are required to do the location analysis. Different type the analysis has to be required to do the before setting up the factory to identify the locations. So that was the location analysis we have discussed. Next we are going to discuss about the what are the purpose, why and what are the applicabilities are there to establish a uniform procedure pertaining to start of a new apparel operations plant. Why we talk about the layout. Now from the location we are coming for the second stage, that is the layout. So we discuss about the location, what are the locations are there, what are the availability of raw material, availability of manpower, trained workforce, untrained workforce, social status, demographic thing. So we discuss in the plant location. Next one we are going to discuss about the second part is basically the plant layout, where we discuss about the purpose, why we are going to even discuss about some formal things about what we are discuss about the standard operating procedure to establish a uniform procedures pertaining to start of any new apparel operations plant. So here in this one we are going to discuss about because the SOP is going to help ensure the credibility, accuracy and competitiveness of all steps in a sequential manner of any plant startup. If you want to start up a plant, so basically if you are having the SOP, standard operating procedure, SOP stands for standard operating procedure. So it's giving the step by step manners, so that it will be sequential manner how we are going to start the plant. What come first, second, third, fourth, fifth, like that. We have the lot, lot of things are there. We will discuss in this particular module. Then the inspector may also deviate from these procedures when necessary due to unexpected or unique problems that may occur. Any deviation must be discussed in this particular module. The procedures of SOP are applicable to all personnels involved in the planning, coordination, preparation and execution of any plant startup. So once what SOP has been made, that SOP has, everybody has to, from top to bottom, everybody engagement is there. Knife machines. So this is the level of automations, whatever is desired in the factory, based on the investment, because everything requires money and the investment is required for each and everything. So what type of investment the entrepreneur is looking for, this has to be discussed in beginning itself, about to understand the complete before going for the complete project, to understand how much investment is the owner is looking for, or maybe the plant startup person will come with the options also, with the highly automatic investment. If you are coming with that, this is the total investment. Second case, this is the investment. Depends on that. Next is the compliant factory. We are looking for the compliant factory or not. Like compliant factory, like the different companies are like we want to have the factories to be certified by ISO certification we are looking for, or we are looking for the buyer end, we are looking for GAP certification, or in fact we are looking for the RAP certification. So different type of certifications are there. What type of certifications we are looking for, that is another thing. If you are looking for the compliant factory, then it is advisable to have knowledge of both local laws and buyer laws, so one could follow whichever is stricter. So local laws is also important, because the compliance, what are the local laws are there, what is the government norms are there, and second thing, if you are producing for a buyer, so buyer laws also important. The compliance has to be followed for social as well as the buyer compliance. The social and technical both compliance has to be followed, and for buyer as well as for the state, the local level also. Then next is basically the inventory planning. Inventory planning, basically the what type the storage we want to give, that is inventory planning. If you talk about the fabric, then in fabric, what is the roll diameter, what is the length? It helps in getting the racks designed preferred for the storage. Further, it will be helpful in planning store and cutting room also. So what is the length of the, what width of the fabric you will get, whether we will get the width of the fabric will be 7 feet or it will be 6 feet, and what will be the roll diameter. Roll diameter will be how many meters of the roll will come in one roll, what are the GSM of the roll of the fabric. So these will also has to be discussed, that from which supplier they are going to get the roll. Then we will discuss about the supplier, what type the average roll length is there, what is the width of the fabric we are looking for. Then in next is basically we will talk about the finishing. In the finishing, we will discuss about what is the cotton, what type the cotton, what buyer, suppose some different buyers have different cotton dimensions are there. That usually cotton dimensions, what are the usual cotton dimensions buyer is having in terms of length, in terms of width, in terms of height. Then type of the packing, it's like in the jacket, we are looking for, most of the packing we are doing for hanger packing. In shirts, in trousers, we are going for maybe flat packing, or t-shirts we are looking for flat packing. So whether it's hanger packing or it's a folded packing will be there. So that has to be given. So these feedbacks are required from the client or from the entrepreneurs before starting any project, and it will be helpful in getting an idea about what an entrepreneur or client is looking for, and it will help in checking the validity of the claims and guide him in logical way. The different thing will be in the logical way is this, all things these questions has to be asked before going in depth about the plant. So once these query has been asked, and client or in the entrepreneurs are also knowing that what he is talking about, and the plant layout person also understand that what client is looking forward. So accordingly the next stage will come forward, that will be the coming as a planning and design of the layout. So once we talk about the preparation of the plant layout, so the after getting the feedback, it will be very clear that whether the client has the land or building ready with him, or they have to look for a new land or lease building. So it's very clear in the, if we have the feedback, based on the feedback, whether the building or whether the space is already available, land is already available, or after discussion it came to know that no, it has to be procurement, still has to be done, or the land procurement or ready-made building procurement has to be done. So the next after knowing this is very clear to the plant layout engineer that these are the situations. If later is in the case where basically the new land, we are looking for the new land or leased building, so basically it's required for optimum utilization of then it's basically the land is not purchased, so we can do the planning according to the requirement, and then we can prescribe that how much area is required and what type of the land is required. So it's usually it is a good to have the factory laid horizontally rather than vertically for ease of man-machine movement. We can go with the horizontal layout, we can go with the vertical layout. Horizontal layout is basically mostly the structure used to be the prefabricated structure, where basically we are going for single floor building. And if it is the RCC, that is the reinforced cement concrete structure, which goes with the vertical direction like the multi-story building. So whether we are going for the horizontal or it's going for the vertical, logically if you are asking that, it should be always easier where the operation cost, definitely the one-time investment will be more if you are going for horizontal layout, where basically the land area requires, some more land area requires than the vertical one. So fixed cost will be more, but operation cost will be less in the case of the horizontal layout where the prefabricated structure is there. Because a person has to travel from, like we have kept the suppose example, we have taken the multi-storage building. In the multi-storage building we have the ground floor, first floor, second floor, third floor, fourth floor. So from ground floor we have kept the fabric stores, first floor we have kept the cutting, second and third floor we are having the maybe sewing, and then final fourth floor we are having the finishing and packing. So from fabric store the goods has to come, the raw material has to move to cutting room. So maybe the aerial distance from here to the to top will be only 10 feet or 15 feet, but the travel has to be done from in the prefabricated structure. The person has to move from cutting room to sewing, from fabric store to cutting room. Fabric store to cutting room, maybe it will be maybe 15 feet or 20 feet, but in multi storage building, the person has to move from this place to the lift or to the staircase with those heavy load, and then he has to take that particular load up maybe another whatever the 10-15 feet. Then he has to move to the cutting, he has to store the goods to the area where we are keeping the rack for the storage. So the distance traveled by the person, and the person has to, if he is doing the manually, then manually he has to take the load and he has to go in the staircase, or if it is the lift is there, then definitely he has to take the things inside the lift. He has to wait for the lift to come. Once the lift is there, he will put the goods inside, then he will reach there, again he will take the lift out. So the time, the money, these are basically going to add more in the operational cost if we are having the multi-storage building. If it is the prefabricated structure where the horizontal plan we are going to have, then we are not going to have that much of operation cost. Then operation cost will be minimum. So whatever the structure we are going to have, we cannot say right now that which structure will be best, because it depends on the cost of the land also. If the cost of the land is cheaper, we want to set up the factory in very interior place, or where cost of the land is very cheap, then definitely we should go for horizontal structure, where basically the land cost is cheaper, Okay, we are going to save in the operation cost. We are not going to pay much in the land cost. But if we are going to have the factory in some urban areas, so in that urban area definitely the land cost will be very high. Even if you are taking in the special economic zone or export promotion zone also, land cost will be substantial, land cost will be there. So there maybe it may be advisable, or it can be depends on the what are the land costs, that we should go with the RCC structure or multi-storage structure, because the land cost is huge one. So fixed cost will be huge, fixed cost is required. So we can go with the operation. So that comparison, that analysis has to be done. That strength, weakness, opportunity threat has to be done before deciding whether to go with the horizontal one, whether it's to go with the vertical one. It depends on these factors what I have discussed right now. So once always better to have with the horizontal one for ease of the operation, but we cannot undermine the importance of the cost. For example, we have taken here like we have going with the horizontal, so for the ease of man machine movement, as well as the factory can easily also supervise. So when the land is not there with the buyer, it is advisable to start with the best layout first as per the method explained, which we are going to discuss, and then ask him to get the land as per the requirement. So as a plant layout engineer, we have to come with that. We have to discuss with the client, with the entrepreneur, that let me first come make the plan. We will tell you how much land is required, how much area is required, and then we will discuss on that particular thing, what are the availabilities are there. So we will discuss that what are the areas, what are the different steps are there in deciding that particular land. Let's assume a case. We are taking a case study where we assume that, suppose that a land area is 1 acre. Now we have to find out the land coverage rule for that particular region. Usually it normally used to be the 40% of the total area which can be covered. So 1 acre is the total area. Out of 1 acre, 40% is the area which can be covered, which usually used to be there. So another factor we have to look out for that is the FSI, that is the floor space index. It tells basically about the area we can cover vertically. Because of the land coverage, we may not be able to cover an acre of the land horizontally, but FSI may allow us to do that in vertically also. So we already got the feedback. We will be clear on the what type the product mix. So far we are clear with the what type the product mix, because the client has already told like some product mix is there or is not there, only one product they are looking for, and what is the ratio. If any product mix is there, what is the ratio in which they will be produced. So next step is basically about the making of the operation bulletin. Operation bulletin is very important here. Operation bulletin is nothing, is a record of equipment types, what type the equipments are required for making of the production of that particular good, what type the machine attachments, what type the work aids we are going to have in that particular place, workplace engineering aid, what are the workplace engineering aids are there, then standard time for each operation, what are the SAM for each and every operations are there. Then it will be extended to include also about the hourly or period target for each operations, manpower requirement, equipment requirement, and it should also it will also cover the operations. It's not only for the sewing, it will also cover which is directly related to the single unit of a product, like the spread and cut, how much time it takes for spreading and cutting, sewing using the manual operations, finishing and packing. So this operation bulletin is a fundamental planning tool to be used for many functions. It also been used for direct labor costing. This operation bulletin is also used for planning, capacity planning, incentive payments, factory loading, manpower planning. It can be method engineering, performance measurements, that also to measure how much the performance the operator is having. So the main thing to concentrate here is basically the number of machines used to match the capacity of the plant. How how many machines are required as per the operation bulletin and how many machines we can have in that particular plant. So, and the good way among few is to decide optimum output for one line and multiply it with the total number of lines. So, basically we can take one in this particular case, basically for setting a factory for one sewing machine, we take other case like if suppose we want to have the 1000 machine factory. For setting up the factory for one sewing machines, normally it requires around 175 square feet of the area. So which take care about the cutting, sewing, finishing, washing, other allied departments like the medical room, crèche, canteen, washing area, locker area, small area for embroidery, fabric store, trim store. So these all things, pagoda store. So these all things will be taken care in this particular. It's only for planning. It's an example we have taken. It's not an hard and fast 175 square feet has to be taken. I am just taking the case study where we are going to do the backward planning to understand that roughly how much area we required. And then after we are going in detail about the each and every department planning, each and every line planning, then we will come to know the exact area, how much area is required, and then we will see that one sewing machine how much area is required. The factor is 175 or factor is 150 or 125. So for one sewing, suppose we are going to have the 1000 sewing machine factory. So 1000 multiplied by 175 will give the total area. So here we are talking about the suppose 500 machine factory we are going to have. So total area required will be roughly equal to 500 into 175 will be 8 lakh 75,000 square feet area. So now generally the ratio between cutting, sewing and finishing, these three departments, generally the ratio used to be 1.1. This is the general ratio of cutting, sewing, finishing department. The ratio, if you talk about the ratio between, this is cutting, sewing and finishing. So this, if you talk about the ratio of cutting, sewing, finishing department, it used to be 1.1. For the cutting we are taking the ratio as 1.1 is to 3 is to 1.3. So this is the general ratio, is normal ratio for a calculation purpose. We are considering this, which is the general normal ratio. This that. So basically this point is basically necessary to check that whether the assumptions held by the client were right or not. If not, then we are going to correct it. So next stage is basically the planning of layout. How we are going to plan, what are the other factors has to be taken into consideration. Next is basically the aisle, AISLE. The aisle is important because we know the area, how much area we required for a man and machine. So it's roughly around 4 square feet, 16 square feet area we require, 4 feet by 4 feet for a one workstation. One workstation in sewing, we require the area is 4 feet by 4 feet. So basically this is 16 square feet area we required in for one workstation in sewing. So now we will calculate, after knowing this, we are going to calculate, we are going to add about the other factors, what are the other areas are also required along with this workplace area. So one of the most important factor in the allocation of the space is very carefully consideration of aisle location, where we are going to locate the aisle. And aisle is also, location and width is also, both are very important. So this is basically different authorities have different typical layout, but it shows like that around 1.2 square feet of aisle for every 1 square feet of manufacturing and storage space is required. So basically, why we are using oil? What is the use of oil? Oil basically we are using, primarily basically we are using for material handling, to handle the material, because that place the area will be the area normally we are keeping as yellow mark, where the movement of man machine material happens. Then personal movement, material movement, personal movement, finished good handling, scrap or waste removal, whatever the scraps or waste is there, it has to be removed, it has to be kept in that particular area. Equipment relocation and replacement, whatever the equipment has to be relocated and placed, and the fire extinguishing equipment access. Oil may be classified as main, that is for transportation. Normally we are keeping the main oil, that is for transportation. We are having the cross, we are having the departmental oil, we are talking about the personal for service maintenance, miscellaneous access to elevator, compressor, etc. So the importance of the oil, we talk about the importance of the oil, plant space in economy, whereas the small building, if you talk about the space, plant space in economy, whereas the small oil building is there, 20 feet oil may have one aisle of 3 or 6 feet wide. 20 feet wide building which is having the 20 feet wide may have one aisle which can be of 3 or 6 feet wide. It will take around 25 to 30% of the total available floor space. A building having the 600 feet may have 3 main aisles, and the down, center and side 300 feet apart, each 10 feet wide, taking only 3% of the space, with secondary aisle raising this to 10 to 12% given to the aisle in the larger plant. So there should be usually be a main aisle through the center of the building, straight if at all possible, starting and ending at the outside of the entrance. So we will below are some points are there what we are going to discuss. So whole cover area should have the 2 aisles. Whole coverage area we should have 2 aisles. One is called primary aisle, and second one is the secondary aisle. Primary aisle normally used to be of 6 feet, and secondary aisle normally used to be around 4 feet, 3 to 4 feet. Then basically aisle, wherever we are keeping the aisle, employees should have unobstructed vision of the workplace from the workstations. That's the purpose. Production related items, that is material, inputs, components to be placed in easy reach of the employee. If layout is multi-storage, then better option to have fabric storage, cutting room on ground floor. So these are we are going to discuss about the what are the layout, what are the basically the features should be there. Different layouts are, different features are there. So this, whatever the layout we are going to make, what are the different features are there. So now we are going to discuss about the micro level. If you are going to discuss the plant layout on the micro level, there are some points are there which has to be considered before getting into detail of each and every section. If you are going in detail about each and every section, so what are the points are there which has to be taken into consideration. The first is that whole covered area should have 2 aisles. One is known as the primary aisle, which should be of 6 feet wide, and second is as a secondary aisle, which should be of 4 feet. And next is basically employees should have unobstructed vision of the workplace from workstation. Production related item, that is material, input, components to be placed easy reach of employee. Next is if employees, the layout, what layout we are looking for is a multi-floor, then better option to have fabric store and cutting room on the ground floor or underground floor, basement, because it helps to reduce the material movement of the rolls. The man movement plan should be like the operator enters the premises, then the operator is going to locker room, then keeping leaving their belongings, then he is going to washroom to just wash his or her legs or face and all, and then the person will go to the production floor. The process is again followed after lunch and reverse while going for a lunch and out of the factory. This flow should be kept in mind while finalizing the layout. That accordingly the workers has reached, and then after workers are keeping their belongings in the locker. So first locker has to come, then after the worker has to go to washroom, and then it will go to the production floor. The temperature requirement is basically the normal temperature should be between 18 degrees centigrade to 29.5 degree temperature. That is the temperature requirement inside the factory. So if you talk about the temperature, it should be between 18 degree centigrade to 29.5 degree centigrade. It has to be maintained inside the factory to have in the layout. So how it has to be maintained, how many insulators has to be given, what windmill we are going to have, or for the source of the energy, or fan, or we are using the cooler. So whatever way the temperature has inside should be mentioned between 18 degree to 29.5 degree. Then we talk about the noise level. If we talk about the noise level at any case, the noise level should not go more than 85 decibels dB. It should not go more than 85 decibels. More than this can be hazardous. It can be a person may have the hearing problems and all. So it has to be maintained as it not more than 85 decibels. So accordingly we have to give the ventilations and all, for that noise level can be maintained. The hazardous materials like the oil, chemicals, other hazardous and combustible material to be stored in secure and ventilated area near to exterior wall of the building, and the same has to be disposed in a safe and legal manner. Next, the HR office should be accessible from both inside and outside of the factory and should be close to the sewing floor. It has to be. Maintenance, because the more manpower used to be in sewing, and they need to have the assistance from HR in case of they have any queries. So it should be close to that. Maintenance and machine storage room should be close to the production floor, because the more machines are there in sewing, and if any maintenance issues used to come, so it will be easier for a production floor to go and talk to them and just discuss it. In the case of any breakdown, they can be easily available. Training should be very far to the production floor, cutting any involvement of new joinees with the factory operators. Wherever is possible, one should avoid long sewing lines. Racks they hinder the movement of man-machine material when moving from one side to other. Maximum running length of a rack should not be more than 88 feet. However, not valid for if you are using the trolleys. No officers should be there on the production floor. No sitting arrangement should be there except for operators inside the floor. Now we are moving next about the planning of each independent section. It is important to know that some points that has been common to the layout of each and every section. So there should be at least two exit, what I have discussed, that on the floor and opposite side of the room. The exit should be on opposite side of the room. Exit door to have a minimum width of 36 inches. The width of the exit door should be minimum of 36 inches, that is of 3 feet. The floor of each side of the exit door should be level on both sides. It has to be level both the sides. The door should be open on outside. The exit door has to be open on the outside. All exit routes must be unobstructed at all times. Exit to be within 200 feet for the all employee workstation to be no more than 200 feet from an exit. The employee workstation should not be at any cost, should not be more than 200 feet. So in the case of the worker has to move to washroom, or worker has to go to canteen, or worker has to come to the office, or he has to go come to the factory and he has to go to home. So whether he is going home, that time also the 200 feet, more than 200 feet, he has to or she has to not travel a distance to reach to the exit door. The fire extinguisher, which is appropriate to the type of the possible fires in the various area of the factory, to be regularly maintained and charged, the date of last inspection to be displayed, and it to be mounted on walls and columns throughout the factory, so that they are visible and accessible to workers in all area. Facility floor maximum travel distance should be 75 feet, or warehouse 1 per 1000 square feet. Fire extinguisher to be mounted on walls and columns, maximum 4 feet 6 inch, that is the 1.5 meters, should be above the ground. So fire extinguisher should be within the 75 feet of any employee. All emergency exit to be equipped with emergency lighting. Emergency lighting should be there on emergency exit, and all exit door emergency lighting should provide at least up to 60 minutes of the power backup. Fire alarms should be placed at each floor, and emergency lights should be placed above exit and on the stair walls. So the alarm, whatever the alarm is there, it should be audible throughout the factory. First aid. In the first aid, basically the factory should have at least one well stocked first aid kit on every floor, and trained specific staff in those basic first aids should be there. Some staffs should be there which has been trained in the first aid, and the name of the staff and the contact information about the staff has to be mentioned on the factory floor. So in the case of any emergency, those can be called for the first aid. The box should be located on the production floor and should have at least one kit for every 100 workers. First aid kit should have the adhesive bandage, it should have the burn cream, it should have the disposable gloves, it should have the flexible fabric handbag, instant cold packs. So these basic medicines should be available, which is available at the counter without a prescription, should be there in the first aid kit. Then factories should have procedure of dealing with the serious injuries that required medical treatment outside the factory. At least 1 to 2 supervisor or other personnel per floor to be trained in the basic first aid for this particular procedures. The next is basically drinking water. They should have at least one purified drinking station for each production floor. It should be clearly marked. Employees should have free access to drinking water at all the times. Then toilets, there should be separate toilets for both gender depending upon the number of employees of each gender. The toilet requirement can be like that. If it is the 1 to 15 employees there, one toilet has to be there. 16 to 35 2, 36 to 55 3, so on, and above 150 one additional fixtures for each additional 40 employees should be there. We should have the gents urinal should be kept in the same ratio, and the restroom should be kept in very ventilated. It should be cleaned with having the soap and other things should be there. One sink per every 50 workers we should have. Toilet should be easily accessible with availability of each floor, and no region restricted imposed on the usage. So cannot reach the reasons for that. And toilet should be provided with the supply of the soaps, towels, toilet papers, etc. Then next is basically the sewage treatment plant. STP are basically needed if there is no gutter line in the area to temporarily storage water waste. So which later on can be taken by municipality. Number of such plants depends upon the people in the factory and the frequency of municipality sewage waste collectors. However, technical persons should be contacted on this particular thing for the detail about that, how much area should be there for sewage, how many lorries should be there. Then next is all stair must have proper railings. Through it is good to have ramp inside the stairs. So these things we discuss about the layout, these are the basic things we should have in the layout. So once person has to move to the drawing of the layout, these are the basic things which is very important to understand the. So today we discuss about the location of the plant, where the plant has to be located, what are the measures has to be taken care, what are the features, what are the SWOT analysis has to be taken once to identify the location of the plant. And second, we discuss about the layout, what are the measures has to be taken. We talk about the, we have to proceed for the layout. So making a plant layout is very, very important, because if the structure of the building is wrong, if we have not decided the basement, the root of the plant is not done properly, then we cannot get a good fruits out of that. So roots are very, very important. Then productivity, efficiency, performance, these all things we will talk. Definitely the good plant layout will definitely give these things in better way, and the output will be better. The productivity of the factory will be better if the layout has been made keeping all the features what I have discussed into consideration. Now we will move further regarding the start of the layout. How to start the layout. We will take example of a category of the product, and we will plant layout, and we will move further. So here for a detailed setting of each department, like cutting, sewing, finishing, and other allied department, let's assume that we are planning to start a 500 machine basic men's shirt factory. The shirt is the full sleeve shirt, and with the one single pocket is there, and we are going to start with the 500 sewing machine factory. Now first the step will be the calculation of the area. We know for the setting of the sewing machines we required approximately 175 square feet area. So suppose 500 machines. So setting of one machine factory, approximately we require 175 square feet area. So suppose we are going to start the 500 machine factory. So the area required is 175 into 500. These many square feet area we required. This will come around 87,500 square feet. So roughly to start off a layout, this is not a hard and fast 175 square feet for per machine. This is not a hard and fast that it requires 175 only. It can be reduced, it can be increased also. Maybe the factory we are having inside the factory of the sampling department, we are the factory having the washing, if the factory has the ETP, if the factory have the canteen, factory have the crèche. So these all things, if we will add everything together, then maybe the 175 will go high. If suppose the factory doesn't have these facilities, factory is only cutting, sewing, finishing, and they have the warehouse for packed goods as well as they have the warehouse for raw material. So in that particular case, what will happen? This 175, what factor we are taking, it may be 140 or 150. This is only for the calculation, basic calculation, that how much area of factory requires. Like suppose a piece of the land, we are having the piece of the land, or we want to decide that how much area is required for setting off maybe 500 machine factory. So suppose we are looking for the 500 machine factory, how much area is required. So in that particular case, we need the approximate area for setting up the factory. So we are going to do the backward calculation. We can have the forward calculation, we can have the backward calculation. Here we are going to have the approximation value, roughly how much area is required, and then we will decide that for each and every department how much area, how much area is required. That particular factor will depend on so many, that particular calculation will depend on so many factors. So we will discuss each and every factor about that. So now after talking about, we will take the operation bulletin and we will zero down the SAM of the basic cert. The next step is to reach the optimum output per line at 100% efficiency after doing balancing. So let's see, it comes around 800 certs per 8 hour per line. So now to match target output, we have to set 10 lines producing 800 shirts per 8 hour per line. Further, it will also be give the number of operators, helpers, line feeders, supervisor and QC to run the line. So now we talk about the figure. What figure says about that? Suppose we are having the operation bulletin, around 848 operators are there, 9 helpers, we will have the line, we will have 2 line feeders, 5 line QC, and this, and the total figure, we will get the total figure about that, how many, what is the line length will be there. So on basis of this particular layout, all department, we will discuss about all the different departments. So first we start with the department that is the fabric store. That is the first and foremost department where the fabric used to come and used to store in the factory. So the fabric store, it should be accessible from both outside as well as inside of the factory, because raw material, the unloading will happen towards the outside of the factory, and inside of the factory it should be connected with the cutting room. So once the raw material we have received the raw material will be going for the processes, whatever the processes are there in the fabric store, and after it will fulfill the process, it will, based on the challan, based on the indent, it will move to the cutting department. So the entry should be there from outside, and exit of the fabric should be there through the cutting room inside. So the two gates would be there, is required. So for store layout, it is very necessary to know the form of which we will receive the raw material. In which form we are going to receive the raw material, that is very, very important if we are doing the store layout or warehouse layout. If suppose we have taken the example in this particular case, that if it is in the form of the rolls, then the diameter, like the roll diameter, roll length, these will play a crucial role in the deciding of the storage area, usually the racks, and hence the layout. So now we discussed that the daily production is around 8,000 pieces per day, that we discuss about the daily production, because 800 pieces per line, and we are going to have the 10 lines. So 800 into 10 lines is 8,000 pieces per day, the production is daily production. Then fabric consumption for solid, taking the fabric consumption for the solid is 1.65 meters, checks is 2.5 meters. So it's 1.65 meters for the solid, and for checks is if the fabric consumption is 2.2 meters. Then total fabric required will be 8,000. So here we have taken the calculation of the requirement of the fabric for, here we have taken the example of fabric consumption that is per garment. Per garment is basically 1.65 meters per garment is for solid fabric, and 2.2 meters is for checks fabric. So here we are talking about the fabric store. In the fabric store, we have taken the fabric requirement, how many meters of the fabric is required. We have started this discussion with the 800 pieces per line we are producing, and we are using the 10 lines. So we are in the factory, we are having the 10 lines. So 800 into 10 is 8,000 pieces per day is the output. So now 8,000 pieces per day the output is there, and here we have taken the shirt order. In the shirt order, basically the fabrics, what type the garments we are assuming that what type the garments will be there in the factory. We will have the solid fabric as well as we will have the checks fabric. The solid fabric, the consumption is 1.65 meters, and checks fabric the consumption has taken as a 2.2 meters. But if we will take the average in terms of that, we will say that we will have more solid fabric will be there, and we will have less checks fabric will be there. So we will take the average. Suppose we are taking the average, and average is taking 2 meters. On an average, for a calculation purpose, we have taken as a 2 meters. So 8,000 is basically the number of garments, then 2 meters of the fabric consumption. So per day, how many meters of the fabric is required? So per day we required 8,000 garments 8,000 into 2 is 16,000 meters of the fabric we required. So total fabric required per day, total fabric required per day is 16,000 meters. Now 16,000 meters of the fabric we require per day. Now number of the days, we will multiply this one with the number of days of the inventory what we plan. So in the fabric store, how many days of the inventory we want to take? So that depends on whether we want to have the 30 days inventory, we want to have the 40 days inventory, we want to have the 20 days inventory, or we want to have the 10 days inventory. Maybe in the lean manufacturing system, we don't talk about the inventory because we don't want any inventory in between. So here in this particular case, as per the discussion with the entrepreneur or the client, we come to know that they are looking for the inventory for 10 days inventory. They are planning for the 10 days inventory. So one day we required 16,000 meters of the fabric. So 10 days inventory, keeping 10 days inventory, total meterage will be 16,000 into 10 is 1,60,000 meters we required. So we require 1,60,000 meters of the fabric to be stored. So we have to, at any point of time, we should have the capacity to store 1,60,000 meters of the fabric. Now we will take about the roll diameter. What is the roll diameter? Suppose we have taken the example of the average roll diameter. The diameter of the roll will be for storage purpose. We require to understand that what form the fabric is coming. We have already discussed that fabrics are coming in rolls. Now for rolls we require two information. One is what is the diameter of the roll, and second thing is that after knowing the diameter of the roll, second thing is what is the length of the roll, that is the roll length. So diameter of the roll, we have assumed that roll is coming with the 1 feet of the diameter. Okay, so 1 feet of the diameter is basically roll. We are talking about the diameter of the roll. The roll length is basically, in that case, it is roll length we have taken as a 6 feet. We are assumed as the length of the fabric plus 1 meter. 1 feet is handle length. So 6 feet plus 1 feet is 7 feet. So roll will come, once we talk about the roll, so roll is having the diameter of the roll, the length of the roll is basically, here it's half feet, here it's half feet, and from here till here it is 6 feet. So 6 feet plus half feet, total is 7 feet. So 7 feet is basically, here we have taken the length is 7 feet. Okay. So the meters on the roll, we have taken the meters. How many meters would be there per roll? How many meters of the fabric per roll will be there? So meters per roll will depends on that. In our case, we are having the meters per roll is 90 to 150 meters per roll. So on an average, we have taken the 100 meters. Suppose we have assumed that 100 meters is there. Again, I am telling this is the calculation we are talking about, that to take any particular, we are assuming the any particular quantity, and then we are assuming what is the roll length, what is the roll width, all things, everything are based on the assumptions to understand the complete process. It's not about that, why this roll is only 6 feet, why not 5 feet, why the diameter is only 1 feet. It's about anything can be there. It depends on the type of the product what you are making. It depends on the type of the mill from where you are getting the raw material. It depends on the order quantity, what order quantity you are having. So everything will be here, will be taken care of that. in this particular case, we are doing the case study. In this particular case study, we have taken some assumptions, and that particular assumption will based on that particular assumption, we'll understand that how the process happens, how we are starting with the layout, how each and every department will be, first calculation of the each and every department will come. So here we have taken the number of how many pieces per day we are making. 8,000 pieces is the production per day. So 8,000 pieces we are making per day. So accordingly, we have to decide how many meters of the fabric we required per day and how many meters of the fabric we required to keep the inventory of 10 days. So 2 meters we have taken as the consumption of the garment, keeping the average of between solid and stripe fabric. So 2 meters is the average consumption. 2 meters and 8,000 pieces per day we are producing. So 16,000 meters fabric we require per day. Now 16,000 meters of the fabric we require per day, and we want to have the 10 days inventory. So 16,000 into 10 will give us the total how many meters of the fabric has to be stored, and we have to plan how many meters of the fabric to be stored in the fabric warehouse. So 1,60,000 meters of the fabric we require to store in the fabric warehouse. Now we are calculating that what would be the dimension of fabric rolls will come, which form the first fabric will come. First we have decided that the fabric will come in the rolls. In the rolls form, what would be the diameter of the fabric? So we have talked about the roll will have the two parameters, one is diameter, second is the length. Diameter of the roll we have taken as 1 feet as an example, and the length of the roll is 6 feet plus 1 feet is the handle, half feet and half feet is the handle. So 6 feet plus 1 feet is 7 feet. The roll basically will come with the 1 feet of the diameter, and the roll width will be of the roll length. The moment we talk about the roll length, so it will have the fabric width plus 1 feet will be we are keeping as for keeping the roll both the sides. Handle we require the 1 feet, so total is 7 feet. So that has already mentioned in the diagram, 1/2 feet and this side half feet, and between you have the 6 feet wide the fabric is, total is 7 feet. So now we are discussing further about the how many meters of the fabric is there in the roll. So suppose we are talking about the 90 to 150 meters average we are getting the fabric. Fabric rolls varies from 90 to 150 meters. So on an average we have taken here the calculation for calculation easiness of the calculation. 100 meter is the average roll we are getting per meter. Per roll we are getting 100 meters. So total rolls required per day is basically we are having the total per day we required 16,000 meter of the fabric. So 16,000 meter of the fabric we require per day, and 100 meters the roll are coming in 100 meters. So per day we required 160 rolls. So per day we required 160 rolls, and for 10 days of inventory, suppose 10 days inventory we are talking about, so we required total roll is 160. So it is basically the 16,000 rolls we required, keeping the 10 days inventory. So here we talk about the how many rolls are there. 160 rolls into 10 days inventory if we are keeping. So total roll will require 1,600 rolls we required at any in the fabric warehouse. Now what will the volume will be there in a truck? In a truck we will have the volume of 960 cubic meters. That's approximately 960 cubic meters we require volume in a truck container. So total trucks required to bring rolls, that is 1,600 will be around roughly 10 trucks. So we require the 10 trucks to bring these many rolls. This means that one truck will be there in the factory each day. Every day we will have the one truck inside the factory. So after knowing that how many meters of the fabric is required per day, after knowing that how many meters of the fabric required for the 10 days inventory, how many rolls are required for 1 day, how many rolls are required for 10 days, how many trucks basically we required, who will unload those many rolls. So now we'll see that. So now we will discuss about the proper space should be there outside the store for movement of at least 2 trucks simultaneously. So we require at least space where the at least 2 trucks can move simultaneously. One can have the loading, which can come for the loading, another truck can come for the unloading also. So the space, once we are doing the layout, the space requirement, we have to understand how much space is required, and accordingly we should inbuild those space, we should give the space in our layout. And the entries to the store should be big for easy unloading of raw material through trucks directly, and proper unloading system should be placed like slide, trolleys, these things should be there, where we are going to create the unloading bay where the truck goods can be unloaded, and the slide and trolleys will be there, where the goods can be transferred from the unloading bay to the area where all the goods we will be keeping inside. Maybe that area is known as a quarantine area or unloading area. Now the store should have these following divisions, what we discussed now. The unloading area, the place should have racks space equal to some percentage of the fabric check we want to happen. That is, if we want 10% of the total fabric to be inspected as per the 4-point system, then we should have total how many meters of the fabric we are getting. So it has to be, then rack space should be at least equal to 20% of daily received fabric, which is this case will be 1600 meters, that is the 30 rolls. So we have to give in the area, unchecked fabric area, we have to give this much of space. Then checking area, next will be, it will go for the fabric will move to the checking area. The checking area, it should include the space for checking machines or tables in case of manual checking. However, the number of tables and machine can be calculated by dividing the total length to the by inspected by the checking speed. See, speed of the checking will play a crucial role. If we are doing the checking for the solid fabric, maybe the speed may be more. If you are doing for stripe or checks fabric, speed may be less. So it depends on the speed also, how much area we require for the checking. Then next is basically the main storage area. After unloading the rolls would move to this place after keeping aside 10% of the total rolls for checking in unloading area racks. And it should have the arrangement of racks for storing fabric equal to inventory plan, that is for 10 days. So 10 days plan, we have the space should be there where the 10 days of the inventory plan can be made. Maximum height of the rack should not be more than 8 feet, or running length should not be more than 88 feet. This particular, the rack height should not be more than 8 feet, because manually if you are keeping the rolls, we will not able to keep the rolls more than the height of 8 feet. If we are using the pallets, or if you are using the forklifter, some mechanical device, in that case the 8 feet can be go further up, depends on the type of the pallet or mechanized device what you are using. But it should not be more than 8 feet if you are using the manually, and the running length should not be more than 88 feet of the rack. So after each 88 feet we should give the aisle for the movement. Otherwise the problem will happen that if the stretch is more than 88 feet, the person who is standing in another side of the rack, suppose this is the rack, we are keeping the racks, we have the small rack is there, somebody is here, he has to come this side. So he has to travel a lot of distance to come here, if it is the area is more than 88 feet. So every 88 feet or another rack, between the two racks, the space should be there after every 88 feet, so that the machine, man-machine material movement can be done. The rack should be slightly above to the floor to avoid excess bending, should be slightly above from the floor, but it is available to use vertical space with proper arrangement of unloading it from height. Now if we use height of the racks as 8 feet, then leaving ground clearance in space between each roll, we can easily place 5 rolls in one column. One column, if you talk about the one column, we can easily place the 5 rolls in one column, and length of 88 feet we can easily place 60 such columns. So we can, in 88 feet we can place the 60 columns, and we have discussed that. This means that 300 rolls can be placed in one such arrangement, and we need around 6 such arrangement to accommodate 1600 rolls of inventory. So we are talking the 1600 rolls of the inventory. So basically we require the 6 arrangements are there, which will be that type, the racks will be there where we can accommodate the inventory of 1600 rolls. The stock lot area, if you talk about the stock lot area, this can be utilized to store any extra or leftover fabric from the current roll lot. The area for this depends upon the space available after allocating a space for this particular period. So after this particular fabric store, next we will move to cutting room. In cutting room, number of pieces to be cut daily is equal to daily production, and that is of 8000 pieces. Keeping 8000 pieces as a quantity, what is the target, and 5% extra we are planning to cut. So that's the 5% extra. It may vary 1% or 0.5%, or maybe it will be 2%. 5% extra we are talking in terms of the capacity. So if 8000 pieces we are going to produce per day, then we are taking the 5% extra pieces of the capacity in cutting room, so that at any point of the time, if we are going for 5% extra cutting also, the cutting will have the capacity to cut these many pieces. So 8000 pieces plus 5% extra is roughly will give me around the 8400 pieces. Here for easiness we plan like the 8500 pieces per day. Roughly we are going to cut 8500 pieces. It will come around 6-7% or 8% of the extra. So average consumption per shirt, in the case of, we talk about the average production in terms of solid as well as checks. So keeping in the mind the average production per consumption per shirt is 2 meters. So total fabric required to cut is basically, keeping in mind of 8500 pieces we are going to cut extra. So 8500 pieces multiplied by 2, it will give the total how many meters of the fabric required per day in cutting room. So 8500 into 2 is around 17,000 meters of the fabric required per day in the cutting room for smoothly cutting of number of pieces what is required, whatever the target is. So we can see from this that we have to plan a cutting room with the capacity of 8500 shirts. So 8500 shirts pieces we have to plan the capacity in cutting room, and for this many cutting of these many pieces we required 17,000 meters of the fabric. That's very clear now so far. So we have taken that 8000 pieces so far, we have taken as 8000 pieces is the quantity, what is the target production, and for cutting room capacity we have planned around 6-7%. So it will be coming roughly around 8500 pieces. So 8500 pieces is we have to prepare, we have to make the capacity of 8500 pieces in cutting room, and 2 meters is the average fabric consumption per garment. So 2500 meters, 2 meters is the average consumption of the fabric per garment. So 8500 into 2 is 17,000 meters of the fabric we required per day. Now the next step what we will be discussing about to decide what marker we are going to plan, which is directly proportional, definitely the marker will be directly proportional to the, we will discuss about the length of the table. What is the length of the table required to lay the fabric? That is, maybe we are taking the example of 6-way marker will require to lay fabric up to 12 meters on one table. So if you talk about the 6-way marker, we require, suppose we are talking about the 6-way marker. So 6-way marker, per garment we are talking about 2 meters per garment is the consumption. So 6-way marker will be 6 into 2 is 12 meters. The table we required more than 12 meters of the fabric we required for more than 12 meters. So definitely our table required more than 12 meters. Then space available in the cutting room, that is, there is no room to put a 12-meter table, then we cannot plan a 6-way marker. So we have to also do this combination. The permutation combination has to be done keeping in mind that what is the space limitation is there in the cutting room. So suppose space in the cutting room, whatever the cutting room length we have decided or we have available length in the cutting room, is not allowing us to have the marker of 6-way marker, so that the table of 12 meters, if we are going for 6-way marker, this marker will have the 12 meters will be the length of the marker. So definitely the table will be more than 12 meters. Table size will be more than 12 meters. If the length is not allowing, cutting room length is not allowing to have the 12 meters table, then definitely we cannot plan a 6-way marker. So we will see for any other alternative. Maybe we will go for the 5-way marker or 4-way marker. So planning stage itself we will try the which way of the marker we have to go for, or so that we have to procure the table, cutting table accordingly. Let's say that we decide to have the 6-way marker. In this case, suppose we have taken the example like the 6-way marker, and my table of around 12.5 feet of the table can easily fit in the whatever the cutting room we have planned. So we have decided that we are going for the 6-way marker. Now the calculation will be the total number of cut in one lay is 6. So total number of cut in one lay of cut we are going to do in one lay is basically 6. So we are going to do the total number of how many garments we are going to cut in one lay is basically the 6 ways we are going to cut. So number of plies, we have taken the number of plies. The number of plies, deciding the number of plies, we used to having so many factors are there before finalizing the how much number of plies will be there. It depends on the what type the fabric is there, like the GSM of the fabric, how extensibility of the fabric is. If we are going for lycra fabric, or we are going for the fabric like the 1x1 rib or 2x2 rib fabric or any other knitted fabric, then we have the limitations. We cannot go for a layer of 12 meters and all, because if you are going for a longer layer length, then the problem will occur that we have cut the fabric, and after cutting of the fabric of these many layers of 6 ways marker, maybe we will find out that to handle such a big layer will be difficult during the cutting, and maybe later on we find that there is some dimensional problem happened. So we, for those type of fabric where we have the percentage of lycra is more, or the fabric which is not very stable fabric, in that case we should go with the smaller layer length, not with the layer length around 11-12 meters of the layer length. So here we have discussed like the fabric is stable fabric, and another thing is that how many plies we can take during the cutting. So it also depends on the GSM of the fabric, how thin or how thick the fabric is. So here we have taken the example like that the fabric lay, the layer is allowing to have the 150 plies of the fabric. So we have taken the 150 ply of the fabric. So number of plies are 150 for the example. Again I am mentioning that this is the one case has been taken here to do the calculation to understand the complete process flow. These numbers will keep changing. We can change this number from 150, it can be 100, it can be 50 also, or maybe the 6 ways marker can be 3 ways marker or 4 ways marker. It depends on that what basically number we are taking, what is the available resources are there, what is the different area. We have to understand about the area also, we have to understand about type of the fabric also, we have to understand the limitation of the machine or equipment what we are using. So these all factors will be there into consideration. Those factors has to be taken care once we are deciding this factor of 6 meters, 6 number of ways of the marker, or we are talking about the number of the plies. So in this particular case we have taken the example of 6 ways marker. We can easily cut and having the 12 meters of, so my marker length will be 12 meters and number of plies are 150. So total garments can cut in one lay. So number of garments, how many total garments can be cut in one lay will be 150, that's the number of the plies, and how many ways of the marker is there, that is 6. So it will be 7. We are talking about the 6 ways. There is some calculation has to be corrected. It is 900 pieces can be cut. 900 pieces can be cut in one particular lay. So total number of garments can be cut in one lay is 900 pieces. Then we have the important thing to consider is the ratio of solid to check. We have the different ratio of the solid and check is, we have taken the example as the 50-50%. We have the ratio of the check versus solid. So a spreading of one lay of solid will 150 ply with a maximum 6 way marker will take around 2 hours. So we are talking about the spreading, that also will come on the operation bulletin, and we have the time study. With the time study we will come to know that exact time, how much exact time will be there. That also can be linked with this particular calculation. So before the calculation we can also do the time study, that how many what is the spreading time, how much spreading time will be there. For roughly we have taken the example that the spreading of one layer of the solid with 150 ply of 6 ways marker. So 6 ways marker, that is of 12 meters of the marker we have taken, and number of plies we have taken as 150. So 6 ways marker and 150 ply will take around 2 hours of the time. So cutting of the same lay will take around 1 hour if done with the straight knife by 2 cutter. So if the spreading time is taking 2 hours of the time, then cutting time will take roughly around 1 hour time. This is again we have talking we have taken some assumptions are there. So spreading time is always high than the cutting time if you are doing it manually, if you are done with the 2 cutters we have used here. So now we are taking about the solid. For the solid, the further calculation of the number of tables required will depend on the cutting time. So the total number of the table is required will depends on the cutting time. That is, suppose if an hour we can cut 900 garments. We have taken the example like the 900 garments we are going to cut in one particular lay. So in one particular lay 900 garments we are going to cut. So is required the time required for cutting of 900 garments, the time required, the cutting time is basically 1 hour and spreading time is 2 hours. So we have discussed about the cutting time is 1 hour and the spreading time is 2 hours. So for 900 pieces we are going to, it is going to take 1 hour of the cutting time. So if then 5 hours the pieces of to be cut with the 6 way marker will be around 4500 pieces. So if we talk about the 1 hour we can cut 900 pieces cutting can be done, cutting time. And suppose 5 hours, how many pieces we can cut? 900 into 5 will give the 4,500 pieces. So we can cut 4,500 pieces in 5 hours. So for the cutting is happening continuously, the cutter should always has the spread ready. So in that case, if the cutting is happening continuously, the cutter should have always pieces ready for the next cutting. For this to happen, we should have a maximum 3 spreading table, as it takes 2 hours to lay 150 plies on a 6-way marker. So here we talk about the spreading table. If you talk about the spreading table, because spreading takes 2 hours of the time, so around 3 spreading table we required, which takes 2 hours of the time, because in between we will have the neck to neck, the cutting or spreading cannot happen. It will take after spreading we have the 1 hour of the cutting will be there, then again the spreading will be done, then again cutting will be done. So this is again I am telling this has only to show the process, what are the processes are there once we decide about the layout. So we have to discuss about what capacity of the cutting we want to have, and accordingly how much time the cutting will take, roughly how much time the sewing will take, spreading will take, and then after we will decide on the tables. So we discuss here we require the 3 spreading tables for cutting of solid. For checks, cutting time of the lay of 150 ply on a 6-way marker is around 2n, because it will require the more time. So now we discuss about the 4 checks fabric. We discuss about the check fabric. Spreading time is required around 2.5 hours. Around 2.5 hours it will be required for, because the check matching, some parameters will be there where you cannot move very fast as we can move in the solid case. Okay, so the checks has to be the spreading time in the case of the checks will require a bit more time, that is 2.5 hours. Then cutting time for the same when we are doing the block cutting. So if suppose we are doing the block cutting for the checks, it will require 1 hour time with 1 cutter. So we are talking about the 1 hour time for the solid. There we are talking about we have taken 2. Here we are talking about the 1 hour time with the 1 cutter. So here we also required 3 spreading table. So here also we require around 3 spreading table. So total, now we will see the total number of tables. Total number of tables what we required will be 3 for solid, 3 for checks. So total will be 6. Number of cutters we required, 2 we required. We talk about the cutters, number of cutters who is going to cut the fabric. 2 plus 1, 2 is for solid, 1 for the checks. So we required 3 cutters. Then we required spreader. So we have 6 tables are there and 2 spreader if you are taking in 1 table. So number of spreaders required is basically 6 into 2 is 12. So 12 spreaders are required, and straight knife we required, number of straight knife is required, that is 4 straight knife. So this is basically in the cutting room, these many cutters, spreaders, straight knife, and these many tables we required, what we discussed here. So from here the cut pieces will move to the band knife. Now what happened, that the cut pieces will move to the band knife, next stage it will move to the band knife. However, checks will be relayed before band knife cutting. So for the solid, cut pieces will directly move to the band knife, because band knife, wherever the areas are there, band knife we are using wherever we have the area, major shapes are there, the where we require the band knife, like the cutting of the armholes, with the straight, the shape is there in the armhole. Those areas where the more deeper shapes are there, we are using the band knife. So it will be going for the band knife. And checks, for the checks fabric, solid will directly go to the band knife. For the checks fabric, it will go for relaying before band knife cutting, because the relaying, we will have the matching parameter in the checks. What are the pocket matching, placket matching, maybe the sleeve matching. So whatever the matching parameter, it depends on the customer, it depends on the type of the check, what type of the check we are going to use. It depends on what is the repeat size. So whatever will be there, the matching parameter has to be followed. Then we will see that what is the SAM, SMB, standard allowed minute. What is the SAM of relaying one whole garment for one operator? So relaying time for one whole garment for one operator is taking 3 minutes of time. That's also assumption is there. We have taken that SAM of relaying on one whole garment while one operator, it takes 3 minutes of time. The total time for relaying of 4,250 pieces, here we have, suppose relaying time is 3 minutes per garment per operator. So number of garments we have discussed earlier, that we are going to cut 8,500 pieces. Out of 8,500 pieces, 50% is the solid and 50% is checks. So 50% of the solid, 2,007, it will be, we will have 4,250 pieces for the solid and 4,250 pieces for checks fabric. So here we are having the total time for relaying of, now we have the 4,200 pieces are there for a solid fabric. So total time is required for relaying of these many 4,200 pieces. So it will multiply by 3. How much time it will require? It will require 25500, these many minutes. So 22550, which translate into 27 relay helpers. So if you translate it into the how many number of helpers are required for relaying, it will be, if you translate it, it will be coming around 27 relay helpers this particular time. Now the time to cut relay pieces on band knife. Now we have whatever the pieces we have cut in the relay. Now time to cut the relay pieces, whatever we have relayed pieces in the band knife, is around 18 seconds. So time to cut relay pieces is around 18 seconds. So 18 seconds is the time to cut the relayed pieces. So on the band knife, so total number of band knives which is required will be 6 band knife. 6 band knife we required. After we do the calculation, we will come to know that around 6 band knives we required for that. So, and 27 relay helpers. So we require 20 relay helpers. Now here we will see that how many relay helpers we required. We required 27 relay helpers. We required 6 band knife machine to cutting the curve areas. Then we have required the relay table. The moment we talk about the relay table, so we required the relay tables are 7 of 8 feet and by 6 feet. So we required 7 tables. The dimension will be 8 feet by 6 feet. This is the relay table we required. So area of the cutting room depends upon the what area required to place all these tables plus given fusing machine, which is the 2-4 collar, cuff, flap and band knife. The last bit, if you plan to have the fusing machine. So the moment we talk about, now we will calculate the area in the cutting room. So keeping all these different tables into consideration, about the relay table, about the spreading table, what we have discussed now, and then on top of that we are having the fusing machine. We are planning to have the large bed fusing machine where 2 for collar, cuff, flap and collar band, because these are the areas are there where the collar, the cuff, we have the flaps and the collar band where the relaying where fusing will required. So and roller fusing machine 2 for front placket. The placket also we require the fusing. So where the 2 we are going for the front placket. So 2 plus 2 basically, one is 2 for the large bed and 2 basically fusing machine. We are looking for the roller fusing machine. So 2 large bed fusing, large bed, and 2 we are going to have the roller fusing machines. So 2 to 4 fusing machines we required here. So die cutting, and then after we have the die cutting. Wherever the die cutting is required, we will use the die cutting. For smaller cutting, we need the die cutting machines. So area of these can be acquired from the, we can get it from the catalog. Whatever the manufacturer catalogs are there, they will give the area for each and every machine, how much area is required for these machines. So we will add those machines catalog. From the catalog we will add those areas, how much area these machines will take, and we will plan the cutting room layout accordingly after adding those the supplier from the catalog will give take this area of these machines. However, when we are using automatic cutting and spreading machine, the calculation which we have discussed just now will depend again on the cutting and spreading speed. What is the speed of the cutting? What is the speed of the spreader in the case of the automatic cutting machine or automatic spreading machine? So these all further depends on the criteria of these machines, and calculation will be done in doing this with it depends on the investment also. So so we have discussed about these machines, how much area required, the cutting table, how much area required. The next is basically whether it's a manual cutting, manual spreading, or automatic cutting, automatic spreading. Automatic cutting, automatic spreading, we should know what is the spreading speed, what is the cutting speed in that particular whatever the fabric we are going to use, and then using that particular concept we will understand that for cutting of we are going to cut 8,500 pieces, that is the 50% solid, 50% checks, how much time is required. So once we know this, then after we can go with the cut order plan. We can go with the cutting room layout. However, the aisle running in the cutting room between tables will follow the specifications that we are going to give the 4 feet of the aisle space for man movement and 3 feet for the trolley. Cutting room should also have the space for storing cut parts. We have to give the space for the storing of the cut parts, and should be equal to the days of the inventory what we are going to plan, and the calculation of that is already we have discussed in the store section also, that how much we have taken for store section. Then the fabric store section we discuss of how much fabric we required. So here we will have the cut part storage area also, and here we will also keep the storage for keeping of the raw material of that is the fabric. So how much we require? The 8,500 pieces we are going to produce per day. 17,000 meter of the fabric we required to keep, where we can keep. We will have the shelf of the fabric. Fabric should be just fabric racks should be before. Then we will have first fabric racks. Then we will have the cutting table. Then we will have the fusing and all, and then we should have the cut parts. So this flow should be there in the cutting room. So after knowing these things, we can discuss that how much area is required for cutting room. This is the basic calculation. With this calculation, once we are very much clear about the calculation, we can decide the area of cutting room after knowing these factors. Next, moving to the sewing room layout, what are the requirements are there, what are the factors are there for the sewing room layout if you are planning to have the sewing room. For setting up a sewing room, the basic requirement we have to take into consideration, those requirements are the number of machines, helpers and checking tables. how many number of machines are required, what type the helpers are required, and what are the checking tables are required, and definitely the machine along with the operator is required. And the operation bulletin, that will give the figure. Once we go through the operation bulletin, it will give the exact figure that how many machines, workstations are required, how many tables are required, how many checking tables are required, or how many helpers are required. So once we go through the operation bulletin, these all factors will come, and we will understand. We can calculate from the operation bulletin for each and every line, each and every section, how many these workstations are required. So suppose here we talk about the around 500 cert factory we are talking here about. The 500 machines cert factory we are going to start. So total number of machine in the sewing will be 500. So if we say that from the operation bulletin, then operation bulletin for one line will require around 48 workstation for the operators along with the machine where we are having the sewing machines are there. Helper table we require around 9 helper tables, and checking table we require around the 5 checking tables. So from the OB we will come to know, operation bulletin will come to know that number of machines, how many number of machines are required, how many checking tables are required, and how many helper tables are required. So we have the number of machines. We will from the operation bulletin we'll see that number of machines whatever we required is 48 number of machines are required from the operation bulletin, if you see that. And we have the checking tables, basically is the 5 checking tables are required, and 9 we are having the helper tables are required. If you do the total, it will come around it will come exactly 13 and 9, it will be 2, and so we are talking about the around 62 workstations are there, including machines, helping table, and checking table. Now if we know that how many workstations are there, the next step will be the material movement, how we are going to plan the material movement. For an overhead system, if you are looking for the material handling system as overhead, like we are planning to have the overhead system like Eton, Swiss track, or any custom conveyor belt system we are planning to have, the distance between the two machines and two line will be depend on the specification given by the vendor of such systems. Like between the distance between the two workstations, how much distance will be there between the two workstations, because overhead will be running, the conveyor will be running maybe in the some shapes. So what is one workstation we are here, another workstation, this depends on the specification that of the hangers and about the material, how the material flow is happening, how much distance we have to keep, So these all things depends on the what basically the supplier or vendor are giving it exactly, how much basically the as per their particular overhead system conveyor belt, how much is the distance is, so that we can get it from the catalog from the vendor. Next, after this we will plan to have the center table. Suppose we are working in the progressive bundle unit system, we are working on the assembly line system. So wherever we are using the center table, even we are using in the overhead system, we are keeping in assembly line for the parts, and for preparatory we are using the center table. So that particular system also we are having the center table. So suppose wherever we are planning to have the center table in our production system, the production system is another part of the another module. It has been discussed about the different type of production systems are there, what is the requirement of different production systems, how much we are keeping for the center table, what is the width, what is the length we are keeping, and it depends on the how the sitting arrangements are and all are there. So whatever the width of the table should be around 15 inches. If you talk about the center table, we are keeping the width of the table around 15 inches, It can go up to 18 also. Some places they have kept the 2 feet also, like the 24 inches of the table also. So width of the table, here we have discussed about we are planning to have the width of the table of 15 inches for preparatory section and 24 inches for assembly. For assembly we are keeping the 24 inches of the table, and preparatory section we are keeping the 15 inches of the table. Because the preparatory section, the parts are smaller parts, we are making the preparatory section. For a shirt, smaller preparatory section, we are making a cuff, we are making collar, we are making sleeve placket. So these all, so we are talking about the smaller parts, what we are making in the preparatory section. So we require the smaller area, the smaller table of the center table, that is 15 inch is sufficient for that. And for assembly line, even in for parts also, where the bigger parts we are doing, we are having the bigger parts for shirt and all. So we are keeping the 24 inches of the table width. So width of the center table will depends from 15, it will vary from 15 inch to 24 inch. 15 inch we are keeping for preparatory, 24 inch we have kept for the assembly line. Then distance between the two machines, if you talk about the distance between two machines in a line, it should be around 22 inches with or without workade. So whether we are using the workade or we are not using the workade, the distance between the two sewing machines will be around 22 inches. So distance between the two machines, if we talk about the distance between the two machines, is we talk about the 22 inches of the distance between the two machines. So if the distance between two machines are 22 inches, it can be with or without the workade, that is space for entering the workstation should be around 22 inches we are given the space. Then distance between the two lines, basically these are the factors are there what we have to use once we are making the, we are giving the exact line planning. If you are making the line planning between the two workstations, how much this difference should be there. Then between the workstations, we have the center tables. In center table, what should be the width, what should be the length. So we have the horizontal and we have the vertical. Both ways we talk about the how much space should be there. Then it will be always easier to do the line planning, and it will be easier to do the sewing room plan and factory planning. Then we talk about the distance between the two lines. The distance between the two lines should be around 4 feet. That is the straight line distance from end of maximum width machine in a line to the start of the another line of another line. So suppose this is one line, and we talk about the another line. The distance between this line we have just discussed that it should be around 4 feet. Line 1 and this is line 2. So 4 feet we talk about the distance between the two lines should be around 4 feet. Then we have the for trolley movement. If you are using the trolley, for the trolley movement, because in progressive bundle unit system we have the trolleys, and apart from that we are using the trolleys for flow of the material, like if we are using the baker's trolley, or we are keeping the raw material are coming, or cut parts are coming from cutting room to sewing room, it's coming in the trolley. So movement of the trolley is also, space is required. So here we talk about the trolley movement. Instead of the center table, the space will be used for movement of the trolley. So if you are using the trolley, we are using that in the progressive bundle unit system where we don't have the center table, we are using the trolley. So in the place of the center table, we are using the trolley. So within the line, so the space which is required, if the trolleys we are using between the two within the line, suppose this is the one workstations. We are having, this is workstation, this is having the another workstation in the line. So this space, we are talking about this space will be around 8 to 10 feet if you are using the trolley. So trolley, if you are using the trolley, we require the bigger area. If we are using the center table, we require the lesser area. So distance between the two lines should be around 6 feet for easier movement between the lines. So it should be 6 feet between the lines if you are using the trolley. So for any of the system, whatever the system we are talking about, we should avoid long lines. Usually, whether we talk about the conveyor belt system, where we talk about the progressive bundle unit system, we are talking about the conveyor belt, that is UPS system, or we are talking about the mobile progressive bundle system. So we should always avoid to have the longer line, because the distance traveled by the operator or supervisor or man machine material will be long distance we have to travel if you have the longer lines are there. So in any case, whatever the production system we are keeping, the distance between the line length should not be more than 88 feet, because it's result in increased movement from one side to another side. Somebody wants to move from one side to another side, there should be always, it takes long time. So we should keep a break between 88 feet. After every 88 feet we should keep the break where the movement can happen. Then the placement of the machines should be such that one side of the operator should always be free for movement. We should keep the machine in such a way that one side of the operator, it should be always free for the movement. We should not obstruct the operator for the movement. So when we are using that center table of the operator, either side of the table should be face each other, as this way they will always be disposing to its right side, which has the center table. So if you are having the operator is sitting and the center table is there in the right side, left side should be free, or operator is sitting where the center table is on the left side, right side will be free. So one side should be free, unobstructed, so that the movement of operators can happen easily. Then we can have the pigeonholes, we can have or post box we can create, should be placed one at the start of the line. Before start of the line we can have the post box. The structure of the post box, we also say that the post box or name is pigeonhole also. The structure is like this, where basically we have the small separators are there, and then we are having the what we are using in the later in the post office also, this type of basically structure is there, where one basically this is the one cell, then another cell, then another cell. So this post box should be there between start at least we are keeping the two pigeonhole or post box at one as the start of the line before the preparatory to store cut parts, to load to preparatory, and one after the preparatory and before assembly to load parts in the assembly. So once the preparatory or parts has been to be ready, before that we are keeping before the preparatory, and one we are keeping after the preparatory and between the before the assembly line. So two pigeonhole at least or two post box we should keep it, where we can keep the bundles we can keep in this particular each and every section. The whole will be assigned for different bundles. Then attention, we should also have the attention should be laid on fact that flow of work should be smooth in the line with proper demarcation as to how to handle with move in the line. So the bundle, how we are going to move the bundle in the line, the proper demarcation should be there. So these are basically the once we are talking about the layout for sewing room, these are the factors we should take into consideration before deciding about the layout of the sewing room. Then next we are moving for the finishing room layout. The finishing room layout, the layout of the finishing depends upon the product. What product we are going to make is being produced. Whatever the product we are going to make was being produced, it depends on the layout on that particular category, that particular factor. However, the flow, what we are going to explain it, that is the normal flow used to be there, that after the sewing line the pieces used to come for trimming, and after the trimming pieces, if it is the wash garment, it will go for washing. If it is a non-wash garment, it will go for checking. So if it is wash garment, it will go for washing, again it will come back from the washing, again whatever the extra additional thread, which will be, it depends on the wash, whatever the wash we are going to use. If you are going to do the heavy wash, then definitely there is a chance like the where we have the some threads can come out. So we can go for another set of the trimming, and whatever the way, after the trimming, next step is basically the checking. We will go for next way is basically go for the initial press, and then after it will go for initial because initial press we are doing so that the whatever the wrinkles will be there, it will be taken off, so that it will be easier for the checker to check the particular garment. So after initial press, the checking will be done. If the checking the garment is looks okay, then it will go for the final pressing. After the final pressing, it will go for the final checking. That is final checking, where basically we are also going to do the checking, which is after that one we are having the audit also. So then the next process will be the tagging. Tagging basically will be doing as a start of the packing and tagging, and then the final packing will be done. So the steps are basically after the sewing, it is coming for thread cutting. The garments are coming for thread cutting. After thread cutting, if the garment is washed garment, it will go for washing, or if it is non-washed garment, it will go for the next process just after the threading thread cutting. Suppose if the washed garment will go for washing, again it will come back to for the trimming, where the whatever the heavy during the heavy wash, if the some threads, chances are there that some threads will come out, that will be cut, and then it will go for initial press. After the initial press, it will go for initial checking. Then after initial checking, it will go for final press, and after the final press, it will go for the final checking, and then tagging. Then it will put inside the poly bag, or if it is a hanger pack, it will go on hanger. So in this particular case, we are go for flat pack because of shirt. So it will go for inside the poly bag, and then after it will go in the packing room. So if there is no wash, then we can have a packed poly bag output from end of the sewing line. As in this case, there is no need to sort the pieces shade and size wise. For washing, then all these processes should be a part of the finishing area, and the space should also be allocated to sorting before cut and pack. So this is about the washing and packing. So apart from that, we are also giving the layout, we are making the provision for effluent treatment plant. If there is a washing in house, then ETP cannot be dispensed with the apparel park have centralized ETP, but it is critical to check their capacity. If we are having the central apparel park is there, where we are having the centralized ETP is there, if you are going for washing, then ETP is required, because whatever the water will be discharged, it has to be treated. So the ETP is required. If we are having the factory in the apparel park, then maybe they will have the centralized ETP, but we have to check that what is the capacity of that particular centralized ETP, or how much water can be discharged. The main purpose of ETP is to recycle the chemicals, rich water, so that it can be used for gardening, it can be used for mopping, it can be used for cleaning, it can be used for the toilet and flush and all. Actually, the need of the ETP and ETP depends on the local laws. We have the different states laws and local laws, that depends, how much water we are going to discharge. So these laws are there, which is the local laws. Whether the factory, to understand that whether the factory should have zero discharge percentage, how much percentage discharge is allowed. So the different places, that also changes. Then after ETP, we discuss about then after we are having the different final two stages are there, that is final audit and then carton packing. That should be done in the finishing room, whatever the case it may be. So now if we discuss about the calculation, we have discussed about the steps of the area required for the major operation in the garment factory. So these all calculated, after this calculation we will understand that how much exact area we required. So our first calculation has to be done to understand the area, whatever the area is required for in that particular that department. and accordingly we can do the department planning. Apart from this, other departments are also required, where basically which are the allied department apart from this fabric store, cutting, sewing, finishing. Those departments are, and for those departments also we can make the separate layout. These departments are internal laboratories like small to check the GSM, to understand the how much is the shrinkage is there for in the different lots, to understand that how much the color fastness is there. These small things we can do in the internal lab rather than sending it to outside for testing. It will take more money also, and it will be time consuming also. So internal laboratories are nowadays, factories are keeping their internal laboratories to check their the shrinkage of the fabric, to see the color fastness of the fabric or other raw materials, to check the GSM of the fabric, whether whatever the buyer GSM is there, what we are getting from the supplier, both are matching or not. Then we have the CAD room. In the CAD room, basically the pattern we are making, the pattern we are making, we are doing the digitizing process, we are doing the plotter is there. So these all things has to be taken care in the CAD room. The space, how much space required for one workstation, and how much space is required for digitizing, how much for keeping the digitizer, how much space we require for the plotter. So this also has to be done in the taken care in the calculation. Then next will be the cutting room waste storage, because whatever fabric, like we are using, the market efficiency is around 90%. So 10% of the fabric will be, we are going to use around 10% of the fabric. Those 10% of the fabric, whatever the cut wastage will be there, we are keeping in separate section, which can be later on sold to some small retailers who are basically using those particular fabric for a toy industry, they are using for the carpet industry and all. So those waste we are going to store, we are giving the one space for the cutting room waste. Then a training center where the training of newcomers can happen. The training center has to be also planned based on how many people we are planning to train every day, every month. Those based on the capacity of that, we will allocate the number of machines. And in the training center, what are the we are going to use apart from the sewing machines? What are the other tools we are going to use? The space, like the other tools are maybe pegboards for the finger dexterity test. Then we are having the needle and thread can be done. So ball and tube test. So these different tests are there, which can be also used in the training to increase the speed of hand and the movement of the fingers and all. So training center also we can plan. Then maintenance room, like the how big we want to have the maintenance depends on the number of machines, how many number of machines we are having in the factory, how much we are going to do the preventive maintenance, how many machines will be going for the preventive maintenance per day, how we are going to do the preventive maintenance, how many machines we are expecting this will have the breakdown. So these all things has to be taken care once we are deciding for the maintenance room. Then how much machine storage area we want to give. Like some machines are there, we are using the special machines, and those machines maybe for one style that particular machine can be used, another style that machine will not be used. So whatever the extra machines are there, so where we can keep those extra machines, that will be the machine storage we are keeping. Then we have the provision for the metal disposal, whatever the metals are there, even the needle breakage, after the needle gets breakage, so even the whatever the scissor or whatever the metal are getting break is there, those particular metals where to dispose it, the provision of the metal disposal should be there. Then office space for 25 to 30 people and the sample room. These provision for the office space and sample room also should be made, depends on the where the office should be there, how big the office will be there, what are the equipments will be there in that particular office, how many people will be sitting in that particular office, that particular cabin. So these all things has to be taken care before we are planning the space allocation has to be given for that. Then compressor room, diesel store, generator, parking area, these all things has to be there. Then staff dining room, medical room, then crèche. Like if you are having the female operators, so mostly female operators, we require the crèche where they can keep their child to to play, and somebody will be there to take care about the child. And then the area should be there, the medical room should be there. Then next is worker canteens, the total area required for setting up the worker canteen, that is depends on whether the canteen is having the cooking facility or not. If the canteen having the area for we are giving the provision of without cooking, then around 10 to 15 square feet per person we require the canteen space. If we are giving the area with cooking, then in that case around 25 square feet per person we required. So then apart from this, we have made the physical layout. These are the things of the physical layout where the we are having the different departments are there. Apart from different department, we are having the allied departments are there, which is required in that along with the main cutting, sewing, finishing and packing department or fabric store department. Now next stage is that in the layout after the physical layout, next stage of the layout will be the electrical and pneumatic layout, because what would be the load of the, how much load we are giving, depends on the what type of machines we are using. Different type of machines have the different requirements are there, and those different requirements has to be fulfilled once we are doing the electrical layout. Once we are doing the wiring, we are keeping the bus bars. Bus bar, even for the bus bar, where to keep the bus bar is basically where we are giving the points for the supply of power supply. Like in the sewing line, we are keeping the bus bar. Bus bar can be overhead. We can have, if it is the center table we are having, then we can keep the bus bar also along with the center table, or we can keep the bus bar underground also. So different type of systems are there. If you are keeping the bus bar on overhead, then the plug points will be kept on the overhead. So suppose we are keeping the bus bar, this is the machine position, these are the machine positions are there, and we are keeping the bus bar here. This is the bus bar. So the machine plug points will be like this. Here we are putting the machine plug points, and we are getting the tube lights here. So what happens, it will normally, if you are keeping in the overhead, there is every type of the layout has some merits, some demerits are there. If you are keeping the overhead layout for the bus bar, if you are keeping overhead, in that case the look of the factory, there you will find the hindrance is there, because the wires will be hanging from top to the machine. So both the sides it will be hanging, so it will not give the clear view of the factory. But it has a merit that it can be, if it is the overhead bus bar is there, so shifting of the machines will not have problem. If you are keeping the bus bar in the center table, so if you are changing the layout, like number of machines for different style is required less. In that case, the table, if it is already fixed with the table, so take out the table or change the layout will become very rigid. It is very difficult to change the layout later on. But it will give the nice look where the wires will not be visible from outside. In the first case, wires will be visible from the outside. Or we can have the bus bar we can keep inside the floor also, where basically it is more flexible. In that case, where its center table will be more rigid and it will be more, so here it will look very neat. If you are keeping underground, a bus bar will be there inside the floor, so it will very neat. It will not create any hindrance also, and it will also not very rigid structure. But one problem is there, if you are keeping the bus bar underground, maybe due to some water seepage, or if we are doing the mopping inside the factory, so there are chances like that. If there's hole has been created, then there are chances of the bus bar will get damaged, or the system will get damaged. Or in the case of any damage happens, then we have to take it from underground. So it is maintenance will be difficult in that particular case. So whatever the electrical system we are planning to have, the lux level plays a important role. How much intensity of the light we want to give, we have to give. The lux level for each workstation should be proper as to provide adequate lighting. So we require the adequate lighting, whether it's a store or warehouse, whether it's general lighting or we want a specific lighting. So different departments require the different department requires different intensity of the light, or different operation require different intensity of the light. So it should be adequate enough. The recommended lux level for each and every department we can discuss like that. Its recommended lux level is around 800 to 1000 lux in the fabric inspection. During the inspection of the fabric, we require around 800 to 1000 lux of the light. Or it's also vary if we are looking for the fabric which is very intricate, where basically the more focus is required, maybe lux level we require more than 1000 also. So it depends on the type of what type the raw material we are going to check. But roughly it's around 800 to 1000 lux level is recommended, lux level is required in the fabric inspection. Then cutting room we require around, where we are on the table where the knife is moving, that place we require around, because 1000 lux, because the cutter has to move the knife keeping that the line, whatever the line we are having on the in the plotter, whatever the fabric, whatever the pattern shapes are there, whatever the lines has been given, so those line has to be cutter has to follow that particular line for the shape of the pattern, according to the shape of the pattern. So it's very intrinsic. We require the very focused job. So that's required around 1000 lux of the light on the tabletop. Then sewing, once we talk about sewing we talk about the needle point. At the needle point on the machine bed, at the needle point we require around 800 to 1000 lux at the needle point. That also depends on that. If we are using the light color fabric, maybe white we are using, or aqua color, or some light shade fabric if we are using, the lux level of 800 may be sufficient. If you are using the fabric which is a darker color fabric like the black fabric, or some very dark color of the fabric we are using, so in that case lux level requires more, because it will absorb the light, so ultimately the reflection will be less on the eyes. So we require the more lux level of the light. Normally in the sewing room we try to have the localized light. And finishing, again it's required, because the finishing checking will be done. It's very intrinsic, the checking is because the finishing the point where after that the packing will start. So we cannot afford to have any damages or anything whatever has not been seen or has not been found out during that stage. So that is almost the final stage. After that packing will start. In finishing we require around 1000 lux. So electricity layout plan should be based on how much number of the power connections we are looking for, number of distribution center, what are the distribution centers are there. Then it also depends on the connection from the distributions should be planned in such a way that uniform distribution of all the phases should be there. The separate distribution for light, fan, exhaust fan, separate for machines, so that any fault in one type of it should not shut down the complete thing. So we should have the separate distribution center for light, separate distribution center for fan, separate distribution center for the machine, so that if any fault also happens, suppose some problem happen in the fan distribution center, so it should not basically stop the sewing machine machine also, and should not stop the tube light also. So it should have been separate. The maximum row of 8 tube lights to have the 1 MCB. We should have at least every 8 tube lights 1 MCB should be planned. All electrical panel will create a circuit breakers. The electrical, whatever the electrical we are planning should have the circuit breaker to cover, and the properly labeled by identify the source. should be also labeled to identify the source. Access to the electrical panel to have clear 36-inch space and to be free from obstruction on front and sides. Electrical cords to have maintained in good condition, continuous in length and without splices or tapped repairs. Wires, cable and pipes has to be prevented from crossing through doorways or into other work area, because it can damage. If you are crossing through the doorways, it can damage the wire or it can damage the pipes or cables. So we should always try to avoid if it is crossing through the doorways. Power cords on the production equipment needs to be grounded, that is contain a third bronze. So it should be very grounded to keep on to avoid any damages there. And light should be properly perpendicular to the machine head. So light, if you talk about the light, if it is the machine head is there, this is the machine and the operator is sitting here, this place is the needle point. So light should be here, this place the light should be, and almost slightly it should be in the left side of the operator, but not too much of angle, because there should not, in this needle point, it should not have any, we can say that shadow should be there. So it should be in the little left of the machine head, and it around the 6 to 9 inch, we can say that, and it should not have any shadow on the right hand side. Next is basically once we talk about the next. So next is for a pneumatic layout. Once we talk about the important thing, the size of the compressor, which depends upon the pressure required in the factory. How much pressure is required in the factory? Accordingly, we decide about the size of the pneumatic, because so many machines are there which requires the pneumatic lines, which require the some machines like the overlock machines. Even we require the button hole. We required in the pocket turning machines, or we require in collar turning machines. We require the pneumatic lines. So these breakers, whatever the pressures are there, these pressures required in the factory and the type of the air, whatever that is required. The whole preparatory section should have pneumatic point after every 4 to 6 feet. Pneumatic line should be in the preparatory section every 4 to 6 feet. It should be there. A pneumatic point should be also present in the maintenance and should be present in the sample room also. While doing the tanking of electric, pneumatic and steam line, a specific sequence should be followed, where electrical line should be on top, followed by the pneumatic line, and last we should have the steam line. So we have this sequence has to be followed for electrical, for pneumatic and for steam lines. So apart from this, the detailed layout plan, we can also plan for the workate, that what type of workate we want to have, like any front extension we want to give in. If suppose the pieces are bigger, pieces are there, if somebody is doing the, like for example, solder operation. In the solder operation, somebody is doing the solder operation where the pieces requires the bigger pieces, and maybe the length of the bed, machine bed, will not be sufficient. So we are giving the additional bed, maybe we are giving the extension in the bed. Those different type of extensions are we can give, that is the workates, a part of the workates. So those workates, we can have the left extension, it can have the front extension, it can have the right extension, where you can keep the pieces for handling, to make the handling more easier. We are giving these extensions. We can have the workate like wire mesh bin we can give in the front of the machine, where all the parts whatever we are showing, it will be disposed in that particular machine. So that particular wire mesh, whatever the wire mesh we have given that one, so there the parts can be disposed. So whatever different type of the workates are there, that also planning has to be done at this stage, so that keeping those workate space also into consideration, we have to plan that the line layout. So basically line layout, we have discussed about the physical layout, we have discussed about the electrical, pneumatic layout. We have in the physical layout, we have discussed the different departments are there. each and every department different calculations are there. Based on that particular calculation, we can understand that how much area is required. So we have seen the calculations for fabric store about the how rack calculation is there, how many meters of the fabric is required, how many days of the inventory we want to have. Cutting room, we discuss in the cutting room how many tables are required, how many manpowers are required, how much space we should give between the two tables. So, and what are the equipments are there in sewing room, how big the, if depends on the number of the machine, how many machines we want to plan in the sewing room, accordingly the layout can be planned. Then finishing room also, we have seen the different activities are there in the finishing room. Accordingly we can plan for each and every activity we can plan the space. And then we have discussed, after this we have discussed about the canteen also. If it is the canteen is with kitchen or without kitchen, so different we have the different factors are there. On that particular factor we have to do the space calculation. Then we discuss about the medical room, crèche room, we discuss about the parking area, we discuss about DG set, we discuss about the sampling room, offices. So for each and everything we have the calculation, and based on the calculation, if we are very sure about the calculation, about the number, about the factors, what are the factor has to be taken care, then it will be very easy to proceed for the layout. The basic objective of layout is to ensure a smooth flow of work, material and information through a system. The basic meaning of facility is to space in which a business activities take place. The layout and design of that space greatly impacts how the work is done, the flow of work, materials and information through the system. The key of a good facility layout and design is the integration of needs of people, personnel and customers, materials, that is raw finishes and in process, and machinery in such a way that they create a single well functioning system. Small business owners need to consider many operational factors when building or renovating a facility for maximum layout effectiveness. These criteria include the following: ease of future expansion or change, flow of movement, material handling, output needs, space utilization, shipping and receiving, ease of communication and support, impact on employee morale and job satisfaction, promotional values and safety. Facility layout must be considered very carefully because we do not want to constantly redesign the facility. Summarized Weiss and Gerson. Some of the goals in designing the facility are to ensure a minimum amount of materials handling, to avoid bottlenecks, to minimize machine interference, to ensure high employee morale and safety, to ensure flexibility. Essentially, there are two distinct types of layout: product layout and process layout. Product layout is synonymous with assembly line and is oriented towards the product that are being made. Process layout is oriented around the processes that are used to make the product. Generally, product layout is applicable for high volume repetitive operations, while process layout is applicable for low volume custom made goods. Offices and manufacturing facilities are typical design in different ways, a reflection of the disparate products that the two entities make. A factory produces things, wrote Stephen Cones in facility design. These things are moved with conveyors and lift trucks. Factory utilities including gas, water, compressed air, water disposal and large amount of power, as well as telephones and computer networks. A layout criteria is minimization of transportation cost. However, Cones pointed out that the mandate of business offices is to produce information, whether disseminated in physical, that is reports, memos or other documents, electronic, that is computer files, or oral, that is telephone face-to-face encounters form. Cones wrote that office layout criteria, although hard to quantify, are minimize communication cost and maximize employee productivity. Layout requirements can also differ dramatically by industry. The needs of service-oriented businesses, for instance, are often predicted on whether customers receive their service at physical location of the business, such as at a bank or a pet grooming shop, whether the business goes to the customer's home or place of business to provide the service. That is as with exterminators, home repair businesses, plumbing services, etc. In the latter instances, these businesses will probably have facility layout that emphasizes store space for equipment, chemicals and paperwork rather than spacious customer waiting area. Manufacturers may also have significantly different facility layouts depending on the unique needs that they have. After all, production challenges associated with producing jars of varnish or mountaineering equipments are apt to considerably different than those of making truck chassis or foam beach buoys. Retail outlets comprise yet another business sector that has unique facility layout needs. Such establishments typically emphasize sales floor space, inventory logistics, foot traffic issues, and overall store attractiveness when studying facility layout issues. Kohn also observed that differences in factory and office layout can often be traced to user expectations. Historically, office workers have been much more concerned with status and aesthetics than factory workers, he noted. A key consideration in many office layouts is who will get the best window location. To show this status, executives accept in addition to preferred location to have larger amount of space. Generally, a person holding a higher rank expects more privacy or more plus physical surroundings. In addition, Kohn also stated offices are designed to be tasteful and to reflect the organization's approach to business dealings. Conversely, in factory setting, aesthetic elements take a backseat to utility. Given this emphasis, it is not surprising that a general rule office workers will enjoy advantages over their material production co-workers in such areas as ventilation, lighting, acoustics and climate control. Facilities should be designed so that they can be easily expanded or adjusted to meet changing production needs. Although redesigning a facility is a major expensive undertaking not to be done lightly, there is always the possibility that redesign will be necessary, said Wes and Jerson in his book Production and Operation Management. Therefore, any design should be flexible. Flexible manufacturing systems most often are highly automated facilities having intermediate volume production of a variety of products. Their goal is to minimize changeover or setup times for producing the different products while still achieving close to assembly line, that is single product or production rates. The facility design should reflect recognition of the importance of smooth process flow. In the case of factory facility, the editors of How to Run a Small Business state that ideally the plan will show the raw material entering the plant at one end and the finished product emerging at the another. The flow needs not be a straight line. Parallel flows use a pattern or even a zigzag that ends up with the finished product back is the shipping and receiving bays can be functional. However, backtracking is to be avoided in whatever pattern is chosen. When parts and materials move against and across the overall flow, personnel and paperwork becomes confused, parts are lost and attainment of coordination becomes complicated. Small business owners should make certain that facility layout makes it possible to handle materials such as products, equipment and containers in an orderly, preferably simple manner. The facility should be laid out in a way that the conducive to helping the business meets its production needs. This aspect of facility design includes everything from making sure that traffic lanes are wide enough to make certain that inventory storage warehouses or rooms utilize as much vertical space as possible. The J.K. Lazar Institute counseled small business owners to leave ample room for this aspect of operation. While space does not tend to fill itself up, receiving and shipping rarely get enough space for the work to be done effectively. It's said in How to Run a Small Business. Facilities should be laid out so that communication within various areas of the business and the interaction with vendors and customers can be done in an easy and effective manner. Similarly, support areas should be stationed in area that help them to serve operating area. Since countless studies have indicated that employee morale has a major impact on productivity, Weiss and Jerson counsel owners and managers to heed this fact when pondering facility design alternatives. Some ways layout design can increase morale are obvious, such as providing for light colored walls, windows in a space. Other ways are less obvious and not directly related to the production process. Some examples are including a cafeteria or even a gymnasium. In facility design, again, though, they are cost to be traded off. That is, does the increase in morale due to a cafeteria increase productivity to the extent that the increased productivity covers the cost of building and staffing the cafeteria? If the business commonly receives visitors in the form of customers, vendors and investors, the small business owner may want to make sure that facility layout is an attractive one that further burnishes the company's reputation. Design factors that can influence the degree of attractiveness of a facility include not only the design of the product area itself, but the impact that it has on, for instance, the ease of fulfilling maintenance or cleaning tasks. The facility layout should enable the business to effectively operate in accordance with occupational safety and health administration guidelines and other legal restrictions.